At this point in the course, we already learned a lot about React, and we built a couple of demo applications. But there's one characteristic which all demo applications shared. Everything happened on one single page in the end. Sure, the user interface changed from time to time upon certain actions, but it was all on one page, and the URL therefore never changed. It was always the same URL no matter what happened on the screen. And indeed, that is one of the core ideas behind React.js, that you can use it to build single-page applications where client-side JavaScript takes care about changing what the user sees, and it's technically always the same page. Now, that has its advantages, but it also has disadvantages. Most importantly, we lose one of the biggest advantages of the web, the advantage that we can link to certain resources. Because the more complex your applications get, the more you might want to be able to link to certain parts of your website and your web application. Instead of forcing users to always start on the start page and then navigate to different areas manually, it would be nice if users could be linked to certain pages. If you could provide a URL that loads a certain part of your website when visited. After all, that is how most websites work, and at the moment in our React applications, we lost this behavior. That's where single-page application routing comes into play and where this course section becomes important. Because in this course section, you will learn how you can still build React applications that are technically single-page applications, so where we don't fetch new pages from some backend all the time, and you can still have different URLs leading to different pages, so to say, of your overall website. So that you get the best of both worlds. You can still build a single page application, as you will see throughout this course. You can leverage all your React knowledge, and yet you can have different pages with different URLs to which you can forward users and which can be loaded by inserting the right URL in the browser address bar. And therefore, in this course section, you will learn what exactly client-side routing is and how it works and why you might want to use it, though I, of course, already touched on that over the last couple of seconds. You will then learn how to use a package called React Router, which is the most popular routing package for React applications, which is a package that allows us to bring back that multi-page feeling to our single-page React app. And later in this section, we'll also dive into fetching and sending data, and we'll learn how React Router can help us with that and how it can actually simplify the process of fetching and sending data. Now, before we write any code or install any package, let me again clarify what exactly routing is and why it matters and why we might want to add it to our website. And to understand routing, it's important to keep in mind how the web generally works. When you visit websites, you can typically append a path after the domain name, like /welcome, and that loads, for example, the welcome page of a website. And if you then type a different URL into the browser address bar, or if you click a link that changes the URL, for example to /products, a different page gets loaded. So the visible content of the website changes. That's what routing is all about. Different URL paths load different content on the screen. And that's what we didn't have up to this point in the applications we built in this course, because there we never had an opportunity of changing the URL or reacting to different URLs and loading different content based on the URL. That's what will change in this course section though. Now, traditionally, you would implement routing by simply loading different content, different HTML files for different paths. And that is how you would build a multi-page application, which you typically would build without React.js. Now, with that, you get different content for different paths, but the disadvantage is that you always have to fetch new content. A new HTTP request is sent and a new response is received, and that can kind of break the user flow. It can introduce some lag and slow down your website, and it can therefore lead to a suboptimal user experience. So that's why we might want to build a single page application when we're building more complex user interfaces. With those, you send only one initial HTML request, and then this HTML file with a bunch of extra JavaScript is downloaded, and thereafter the extra JavaScript code that runs on the client will actually take care about adjusting what the user sees on the screen. That's how single page applications work. However, that does not mean that we can't bring back the illusion of routing and that we can't support path changes in the URL and load different content based on the path. Instead, we can add client-side React code that basically watches the currently active URL and that triggers whenever the URL changes, and that then leads to different content being displayed on the screen when the URL changes. So instead of loading new HTML files from the backend, we could add some client-side code that simply watches the URL and then loads a different React component when that URL changes. With that, we're still in a single-page application, but we nonetheless support different URLs and therefore routing. And that is exactly what we'll do and what we will learn about in this course section here. Now for this course section here, I prepared a new project, which you find attached. But it is a very simple project created with Create React App, and it doesn't contain a lot of content, just some basic styles with which we can work, and an empty root component, the app component. And we'll use this project to learn about the basics of routing before we then later in this course section will also build a slightly more realistic project and use more advanced routing features. But for the basic features and to understand how routing generally works, we'll use this dummy project. Now to add routing, we'll start by installing an extra package. And for this, I'll open this terminal integrated in Visual Studio Code, which is automatically navigated into this project folder. Now we'll install an extra package because this routing functionality, this feature of watching the URL and loading different content, is not built into React. And whilst we could try to write our own logic, our own router, so to say, that would be rather complex because there are a lot of nuances and features you might want to have to properly support these URL changes and different use cases. That's why we'll install an extra package with npm install here in the terminal, and we'll install the react-router-dom package. Now this react-router-dom package belongs to the React Router tool. And you can visit reactrouter.com to learn all about this tool and this package. So this is the React Router-dom package in the end. And here you can learn about all its features and behaviors and its entire API. So all the functionalities exposed by this package. But of course, we're going to learn all these key features and also a lot of advanced features in this course here. But it's this package which we'll be using, and it's this package which allows us to listen to URL changes and then load different content. So with this package installed, we can now start adding routing to our application. And this is actually a multi-step process. The first step is that we must define the routes we want to support. So we must define which URLs, which paths we want to support, and which components should be loaded for different paths. That's the first step. The second step then is to activate our router and load the route definitions that we defined in the first step. And the third step, of course, is to make sure that we have all these components that we do want to load and that we maybe also provide some means of navigating between those pages so that our users can move smoothly between the different pages. So these are the 3 steps, and I'll of course start with step 1, and I'll start with it here in my root component in the app.js file. And here we want to import something from that React router DOM package which we just installed. And the something we want to import here is the create browser router function. This is a function provided by this package which allows us to define our routes that we want to support in this application. We call this function, and to this function we pass an array of route definition objects. So here we provide a couple of JavaScript objects where every object represents one route. And we add some properties to define the route characteristics, like for example the path for which this route should be activated. By the way, there also is an alternative way of defining these routes, but for the moment let's start with this way. So here we define our route objects, and these route objects take a couple of properties with which we configure the routes. You should get decent auto-completion here where you can see all these properties, and you can of course also learn more about them here in the official documentation. Now, one key property which you will almost always add is the path property. With that, you define the path for which this route should be active. Now, just to be clear, the path is the part after the domain. So if you have a website like example.com, then this is your domain name here, and this is the protocol, this HTTPS part. But then thereafter, you have a path like /products. Or maybe /nothing if you're just on example.com. But either way, this is your path. /nothing is a path, just as /products is a path. So that's the path here, the part after the domain. And that is what we define here with the path property. So we could, for example, say that this is the route for our main page, for the starting page of this website, and the path could therefore be /nothing. So if we are on our domain /nothing, then this route should be activated. Now, the second important piece of information we typically want to add to our route objects is which component should be loaded when that route is active. That's what I also mentioned before. So therefore here we might want to add a new component, and I'll add a folder named pages here to this project to hold the components that will be loaded as pages by the router. Now, you don't have to name this folder pages. You can use the components folder you already know. You could name it routes or whatever you want. I just use this separate pages folder with a name of pages to clearly indicate that the components stored in there, whilst being regular React components, will be loaded with help of routing. So here we could then add a home.js file that contains our homepage component, which I of course want to export here. And then in here, I could add a title where I say my homepage. So that's of course a very simple dummy component, but it's good enough for the moment. Now let's say we want to load this component when this route is active. So if we're just on our domain.com /nothing. Well, to establish this connection, we add another key property here, and that's the element property. As the name suggests, with that property, we define the element, so in the end, the JSX code that should be loaded when this path is active. So for element, you now define some JSX code that should be rendered to the screen when this route is active. In my case, that's the homepage component. So I'm importing homepage from the pages folder and the home component file. And then here's the JSX code that should become active when this path is active. Now you could have any JSX code here. You could add an extra paragraph that wraps this page or do whatever you want. But very often you will simply render a single component that then represents the entire page that should be loaded. So these are now the first steps. We created the route object with its path, and we defined which component should be loaded when this route is active. Now, before we're going to continue with more routes and more components, let's stick to this single route here in this router, and let's see how we can now use this router. And to use it, we first of all must store the returned value of the createBrowserRouter function in a variable or constant. In this case, a constant called router. We need this constant to then tell React that this router should be rendered to the screen, so to say, or that that router should be loaded and should render the appropriate pages to the screen. And to tell React that this router should be used, we need to import another thing from React Router DOM, and that's the router provider component. Now this component is a regular component which we can use like this in our JSX code. And we could, of course, again, wrap it with other JSX code or add more JSX code to this app component. But in this case, I'm only returning router provider. And this router provider component has a special prop which we must set, the router prop. And the value we pass to the router prop should be a router created with createBrowserRouter in this case. So here I pass this router constant to this router prop. And that's important. This router constant is this value which is passed as a value for this router prop. That's how this works. And now with that, we're rendering the router on the screen and we're activating the router therefore. And the router will then therefore take a look at our URL, see what the currently active path is, and load the appropriate element if that currently active path is supported. So therefore, that's all we have to do to now get started with routing. We can now start our development server with npm start. And if you now visit localhost 3000, you should see my homepage on the screen. And that, of course, is the content of this homepage component, which makes sense because that is the page, or that is the component to be precise, which we are loading if the path is /nothing. And since I just visited localhost 3000, the path is /nothing. Because localhost 3000 is our domain, and thereafter we can think of an imaginary slash being there. We can actually also add a slash and hit enter, and that will load that same component, because this is our domain. So let's add more pages. And for that, I'm first of all going to add another component to the pages folder, and I'll name it products.js. The name, of course, is up to you though. Here I'll add a products page, but it will still just be a dummy page without any actual real content on it. Here I will then return an h1 element where I say the products page. And with that component added, we can also add a route for it. We do that by adding a second element here to this array of route definitions. And now the path could be /products. It is, of course, up to you which paths you want to support, but /products might be a path that makes a lot of sense if we're loading a page that might display some product items. So therefore here, we load /products, and as an element, I want to load the products page. Therefore, we're importing the products page, and we're using it in our JSX code for this element property. And that is all. With that, we're supporting this second page for /products. And therefore, if we save everything and we go back and we enter /products after localhost 3000 and hit enter, we load the products page. And of course, hopefully unsurprisingly, if we delete /products, we load the home page. If we enter something totally different, we get an error, though, because we tried to visit a URL, a path, that's not supported yet. Now I'll get back to errors and error handling and showing good error pages instead of this default page that's generated by React Router DOM a little bit later, though. For the moment, let's just go back to /nothing and dive a bit deeper into the React router. So we now added our first two route definitions. There is, of course, way more we can and we should do when building a page or a website that supports routing. But before we do that, I want to show you an alternative way of defining your routes here. You can define them like this with an array of route definition objects, and in my opinion, this is quite an intuitive approach. But especially if you worked with older versions of React Router DOM, it might also be a bit of a strange approach because in older versions, you actually defined all your routes with help of components and JSX code instead of JavaScript objects in an array. And you can still do this in this version here, in this latest version. You can import another function from React Router DOM, and that's the create routes from elements function. And you can create a new constant called route definitions, for example, and call create routes from elements. And to this function, you pass a bunch of JSX code. To be precise, you import a route component from React Router DOM, and then here you can add your route component like this to create routes from elements. With one wrapper route, you could then add your nested routes here, where every route receives a path prop, like /nothing, and an element prop, which could, for example, load the homepage JSX code. So of course, you might see that this is in the end the same as this route definition down there, just with JSX code and components. And we can do the same here for products and the products page like this. And with that, you're defining all your routes with help of JSX code instead of objects in an array. You can then take those route definitions created with create routes from elements and use that to create your browser router. So if I quickly comment this out, we could also create our router now by calling create browser router, but instead of passing this array of route definition objects to it, we pass the route definitions that were created with create routes from elements to this router. With that, if we save that, we still got our homepage and we can still visit /products, but now we're using this different approach of defining our routes. Ultimately, it is up to you what you prefer. I'll switch back to this object-based solution, but you could also define your routes with JSX code instead if you preferred that. I'll comment out all the parts related to it because, as mentioned, I'll stick to this object-based approach. Now that we saw this alternative approach, let's dive back into more routing features that apply to both types of route definitions. And if we take a look at our basic example app here at the moment, we of course might notice one big flaw. At the moment, we always have to manually edit the URL if we want to navigate from the starting page to the products page and vice versa. And it's of course not very realistic that we want our users to use this website like this, because how would users know which kind of paths are supported here? Of course, we typically want to provide links on the page instead, and we can of course do that. We could, for example, go to the home page, and there we could add some text below the title with a paragraph, and for example say go to, and then add a link with the default anchor element and say the list of products, something like this. And this default HTML anchor element takes a ref attribute, which could lead to /products. That's how we could add a link. If we do that, we'll see that the link appears here, and if we click it, we go to the products page. So that's working, right? Well, kind of. We have a problem with this approach. If you watch this refresh icon here, as I click on the link, you will see that it briefly flashes and turns to a cross and back to a refresh icon. The reason for that is that technically we're sending a new request to the server that's serving this website. Now that server will serve back that single HTML page that makes up this single page application, but what happens under the hood is that we of course load all the JavaScript code again, load the entire React application again, and restart the React application. That's a lot of unnecessary work under the hood that can also impact the site performance, which we typically want to avoid. Because we already loaded all the JavaScript code, we don't want to load it again, and we don't want to restart the React application. We would also lose any context or application-wide state if we do so. So we don't want to switch the page by sending a new HTTP request to the server. With that, we lose all the benefits of single-page applications after all. Instead, we want to have a link like this, but under the hood, it should just change the URL and set it to the URL we're trying to navigate to, but it should then prevent the default of sending a request and instead let React Router know about the new URL and ensure that React Router loads the appropriate element for that new URL. And that can be implemented with another special component that can be imported from React Router DOM. And here I'm importing it in this home.js file because that's where I want to add this link. The new component we want to import from React Router DOM is called link. And as the name suggests, we can use it to construct a link. We use it instead of the default anchor element, and it doesn't have a ref attribute. Instead, we use the to attribute. But there we then still specify the path we want to go to. Now, what the link component does under the hood is it does render an anchor element, but it basically listens for clicks on that element, prevents the browser default of sending a HTTP request if the link is clicked, and instead simply takes a look at the route definitions to update the page accordingly and load the appropriate content. It will also change the URL, but without sending a new HTTP request. So if we create this link here, we still see the link here on this page, but if I now click it and you watch this refresh icon, you see that it doesn't flash and we don't send a new HTTP request. Instead, here we can now use this link, which is provided by React Router DOM. And that is how we should navigate between pages with React Router DOM. So now we added this link here. Now, of course, this site is still pretty basic and it will stay relatively basic, but there are some extra features we might want to add to it nonetheless. Now, for example, we might want to add a navigation bar at the top, which actually lets us navigate between the home page and the products page. That would be something you find on most websites after all. We also might want to apply some default styling and, for example, make sure that the content doesn't sit right on the edges here. Now for that, we could add a new component, which I'll add in a components folder because I won't load it as a page. Instead, I want to include it in other components. And I'll name it main navigation. So here we can add a main navigation component function and of course also export it. And then here we could return a header, which contains a nav element, which contains an unordered list, where in every list item we have a link. And for that, we of course want to import link from React Router DOM like this. And then here we could have a home link and another list item with the products link. And of course, we want to set the appropriate paths here as well and go to /nothing and /products. This could be our main navigation. Now, this main navigation should now be visible on all our pages. So therefore, of course, one thing we can do is we can go to home.js and import the main navigation there and then add it here and do the same in the products.js file. But of course, the more pages we're going to add, the more we must repeat that step. And whilst it would be possible to do that, it would also be a bit annoying. What we might want to do instead is add some layout that wraps all these routes and that simply kind of loads these route components inside of this wrapping layout component. Now you could try to render the navigation above this router provider component, for example, or wrap this router provider component with another component. But this would not work if you plan to add links to your layout, because those links only work if they're rendered inside of the router provider, so to say, not above or next to it or as a wrapper of it. What you want to do instead, and which can be quite difficult to understand at first, but which is how you approach this problem with React Router DOM, is you add an extra route to your route definitions, and you use a path of /nothing, and then here you add an element that actually loads the layout wrapper that should be wrapped around the other routes, and we'll do the wrapping part in a second step. For a first step, I'll add our root.js file here in Pages and name this root layout, for example, and export this here. And then in here, we'll soon add some JSX content. For the moment, we'll just say layout, like this. Now this root layout component will be loaded as the element for this route here. And for that, of course, root layout is imported here in the app.js file. Now to actually wrap these two routes and their components with this layout, we must add another property to this special route here, if we want to call it like that. The children property. That takes an array, and it is actually an array of more route definitions, and we can move these two route definitions into this array. With that, we make these two route definitions here child route definitions of this route. So this route acts as a parent route to these routes, and it acts as a wrapper to these routes. In this parent route element, so in this root layout here, we also have to define where these child route components and elements, so the home page and the products page, should be rendered. And we do that by going to this root layout and importing another special thing, another special component from React Router DOM. And that's the outlet component. This component marks the place where the child route elements should be rendered to. And here we could, for example, add a fragment like this. And then here add this h1 tag where we say root layout. And below that we have the outlet. So this is now the marker, the place where the child routes should be rendered to. So in our case, that would be the homepage and the products page components in the end. With that, if we save that, we see root layout and below that my homepage. And if I go to products, we see root layout and the products page. So now we are rendering this parent element and then the appropriate child elements. The advantage of this approach is that this root layout now indeed does act as a wrapper for these page components. So therefore here, instead of displaying this dummy root layout text, we can include the main navigation component by importing it from our components folder and rendering it above the outlet. If we do that, we see the navigation here above our pages. And now we got this navigation on all the pages and all the pages we might add here to this children array in the future. And having such a root route that acts as a layout is totally standard and totally normal when using React Router. You implement layouts like this by adding wrapping routes like this. And of course, for more complex pages, you could have multiple root routes. For example, one for /admin, which then has a totally different set of children, which might have a different layout that's wrapped around them. So that's the advantage of this approach. You can have path-dependent layout wrappers, just as we're doing it here. Now, with that root layout added, we can also add some styling and add our root.module.css file, for example, where we might want to style the content class and add a margin of 2 rem, top and bottom, and some auto spacing left and right, and maybe also add text align center. We can always change this later, but that's something we might want to add here. And then in root.js, we can import our CSS classes from this root.module.css file, and then wrap our outlet here with the default main element and add this class of content which we just added to this element. And for main navigation, I actually created a styling file which you find attached to this lecture, the main navigation.module.css file. And we can then import classes from that file, from main navigation.module CSS, and then add a special class to the header element, the header class, and add a special class to the unordered list, the list class. And with that, we got this navigation here, and we got a little bit of a nicer styling going on this page. But that's how we can add layouts and how we can utilize them, for example, to provide some general styling and add such a main navigation bar. Now, you might remember that earlier when we visited a route like our domain /abc, we got this error page here, this default error message, which is actually generated by the React Router DOM package. Now, of course, it's not unlikely that over time visitors might accidentally or due to erroneous links provided by us visit pages that they shouldn't visit, that simply don't exist. And therefore, you might want to prepare a default error page that's shown in situations like this. To do that, we could add a new page here called error page, like that. And in here, we could return our error page content. We could, for example, include the main navigation here if we want to. And then below that have our main content where we say an error occurred, could not find this page. That's something we could do. Now, to ensure that we also have the appropriate styling for this main element, we could grab this definition from the root.module file and actually copy that into index.css, add it down there, and apply that to all main elements we find, and remove the root module CSS file, remove this import, and remove this class name, so that we now have the same styling not just for our default layout, which is used if things go right, but also on this error page, which is used when things go wrong. But how do we ensure that this page is used when things go wrong? Well, actually, the React Router DOM package tells us here. We can add the special error element property to our route definitions to define which page should be loaded if an error is created. For that, we can go to our route definitions, and we could, for example, go to the products route here and add the error element prop to define the element that should be loaded when this page throws an error. Now, we'll see situations where this page could throw an error later in this section, but at the moment this page actually can't throw an error. But this root path could throw an error, because actually when we enter a URL that doesn't exist, the React Router DOM package will generate an error, and that error will automatically bubble up to our root route definition, so to the route that is defined for path/nothing. Therefore, here on this special /nothing route, we can add the error element property as well, and then say that for this page, for this route, we want to render the error page as a fallback page if an error occurs. And as I just mentioned, an error will occur because an error will be generated automatically by the React Router DOM package if we try to visit a page that doesn't exist. So therefore, with the error page being imported and being defined as an element here, if we save this, you see that now if I visit /abc or any other unsupported route, we got this error page. And that, of course, is a nicer user experience than showing this default error message that's generated by the package. And that's therefore how we can also support situations like this, where users accidentally or for whatever reason visit URLs that don't exist and aren't supported. We got an error page, we got our navigation, we got links. At the moment, you might notice that we get no real feedback when we're hovering over these links. And you might also, of course, see that we can't tell which link is currently active when we're on a page. Of course, we can take a look at the URL, and of course, the page content might help us understand which page this is. But it's also quite common that the currently active link that led to the page that's active is highlighted somehow. And at the moment, that's missing. Of course, it's such a common behavior that it's quite easy to support with React Router DOM. For highlighting the active link, we can start by going to our main navigation.module CSS file and actually add maybe a hover style for the anchor tag, but also support an active class on the anchor element. And we're targeting the anchor here instead of link because, as mentioned before, this link component provided by React Router DOM does render a regular anchor element. So here we might want to define some styles that should be active when we're hovering over a link or if a link has the special active class, which at the moment it will never have, but which will add conditionally based on whether a link is active or not soon. So here to indicate if a link is active, we could, for example, change its color. And I got a couple of CSS variables here for different colors we can use. We could, for example, try this one here, the primary 800 color with this CSS code. And if we add this code, you see that as I hover over a link, it's highlighted slightly. To make it a bit clearer to see that this link is active, we could also add text decoration underline. And now, in addition to changing the color, we add this underline effect. And I'll do this here for this video recording, since that should make it a bit easier to tell which link is active. Now, at the moment, it's just a hover effect. If we click on a link, it still doesn't stay active thereafter. But that's exactly what we'll add as a next step. To support links that should show us whether they led to the currently active page or not, React Router DOM has an alternative to the link component, the navlink component. Now, navlink is used just like link. You can use it as a replacement for link, but navlink has one special behavior. If you add the class name prop to it, it's actually not the regular class name prop, which takes a string, but instead it's a prop that takes a function. And that function should return the class name, the CSS class name, that should be added to the anchor tag. Now, that function also automatically receives an object from which we can destructure the isActive property. And this object with the isActive property is provided by React Router DOM. And isActive is a boolean that's true if this link is currently active, so if it led to the currently active route, or it's false if it did not lead to the currently active route. So therefore here we can use isActive to conditionally return CSS class A if this link is active and B otherwise. Or in our case, we want to add the active class from our imported CSS classes up here if the link is active, and otherwise return undefined, so no class if it's not active. And we'll do that for the other nav link as well. Add the same class name prop, which takes this function, which gets the isActive property on the object that's passed to the function automatically by React Router DOM. And with that, you can tell that if I click on Home, Home is active. And if I click on Products, Products is active. And Home is also still active. Now, why is that? That's the case because by default, navlink actually checks whether the path of the currently active route starts with the path of one of those navlinks. And that navlink is considered to be active if the currently active route starts with the path set on the link. That behavior exists so that a link could be treated as active even if you're on some nested child route. That's nice to have, but not what we want here for the slash route, since every route starts with slash in the end, so this would always be active for all routes. And that's why React Router DOM also gives us another prop we can set here, and that's the end prop, which we can set to true or false, but we can also just add it like this to set it to true. This indicates that this link should only be considered active if the currently active route ends with this path after the URL. So now this link will only be considered active if we are on our domain /nothing and not if we're on /products. We don't have to add end to this other link because we have no other routes that would start with /products. So therefore now with that, you see that home is now not active if we're on products, but we do see if we're on the home page. And that is some extra feature which we might want to add and which is quite straightforward to add with React Router DOM. Of course, it's totally up to you which active styling you want. By the way, if you prefer inline styles, you can also use that. You get the same function with isActive for inline styles. So here you could then also return some conditional inline style that depends on whether this route or this link is currently active or not. So that's also something you could do. I'm not going to do it here, but I wanted to mention it, that for style, this function form is also supported when using navlink. Okay, we're making good progress and we're almost ready to dive into more advanced features. But before we do that, there are still some other basic features you should be aware of. For example, imperative routing. Right now, we allow users to navigate between our pages by providing links which can be clicked. And I will say right away that this is the default way of providing navigation to users. But it's not the only way. In some situations, for example, maybe because some form was submitted or because some timer expired, you might want to trigger a navigation action from inside code. And you can do this by using another special feature provided by React Router DOM. You can import the useNavigate hook and call that in your functional components to get access to a navigate function like this. And this navigate function can be called to trigger a navigation action, so to switch to a different route from inside your code, so programmatically. For example, here I could add my navigate handler function and connect that to a button. And this, by the way, is something I'm only doing for this example here. Of course, you should not create buttons and then navigate programmatically. Simply use a link instead. But a button is a great way for me to show you how this generally works here. So here I'll add a button where upon a click, I want to trigger the navigate handler. Again, not something you want to do, but good enough for this demo here. And then in here, we can call the navigate function and then, for example, navigate to /products or any other path. If we add this code, we got this button. And if I click this button, we navigate. This time programmatically, even though it's upon a button click, but the button click only triggered a function. And inside that function, we then had the actual code, the programmatic imperative navigation code for moving to a different page. Again, you should use a link instead of this approach, but this is how you would navigate programmatically if you would need to do so, for example, because some timer expired or anything like that. It is something which I also wanted to mention here for completeness sake, even though we don't need it on this page, but you might need it in other applications, and now you know how you can navigate programmatically. Now, to conclude the basics of routing, there's one last yet extremely important, common, and crucial feature supported by React Router DOM, which you will need in almost all applications you're going to build. And for that, let's go back to the products page. It's just a dummy page, and it will stay a dummy page, but there's one thing which we could add here, which you might want to have in reality. Besides just saying something like the products page, it would be quite common to have a list of products on this page. So here we could have a list where we have product 1 and product 2 and product 3. And we could, of course, have an infinite amount of products here. This is just an example after all. Now, it would be quite common to load a separate details page for the different products. And of course, that is what you have essentially on any online shop. You have a list of products, you can click on a product to view the details of that product. Now, in order to do so, what you would typically have is a separate page, maybe called product detail. So the product detail page like this, which we also export. And then here we might want to show the product specific data. Now I'll get back to the product specific part in a couple of minutes. For the moment, I'll just output a title where I say product details. So we want to load this page here for our different products. Of course, that should be easy enough to do, right? We add a new route and then we add some links. But what's now the path for this route? Of course, it could be /product detail, but keep in mind that we typically have different products here with different details. So whilst we always want to load the same component, the data that will be displayed in there will be different for the different products. And it would make sense to support paths like products/P1, so the ID of product 1 maybe, or product-1 like this, and product-2. So we might have different paths for these different products. Now we always want to load the same page. We always want to load the product detail page. Hence I'm importing that page here, the product detail page, and I'm defining it as an element. But we want to load it for different paths. Now, of course, we could add multiple paths like this. Now we have 3 route definitions with slightly different paths. But that, of course, is not a realistic approach, because the more products we have, the more paths must be added, and typically we don't even know in advance how many products we'll have, and we also will add more products dynamically. After all, most websites are pretty dynamic, and users and administrators might be able to add new products. We don't want to edit the code all the time just because a new product was added. So hard coding those different product IDs in the paths like this is clearly not an option. And that's why React Router DOM supports dynamic path segments, or path parameters, as it's also called. You add a parameter to a path, so such a dynamic path segment, by adding a colon and then any identifier of your choice, like ID or product ID. Again, this is totally up to you. The colon is very important though. This signals to React Router DOM that this part of the path is dynamic, so that you actually don't want to load this element for /products:/product ID, but instead /products/ any value that will be used as an actual value for this product ID placeholder. You could thereafter have more hard-coded segments if you needed to, but this segment here is dynamic if you write it like this. Now, to show you how this works, let's save that, and now let's simply manually enter /product/P1, and you see we load the product details page, /product-2, and we stay on this page, or /ABC, so /products/ABC, that is. So now we load the same component for all these paths because the part after /products is dynamic, and we can plug in any value of our choice for this placeholder. Now this placeholder here becomes important once we want to start loading different data for the different products in our case though. So we added this dynamic route here, or this route with a dynamic path. Now let's say that on product detail page, we of course want to know for which exact product this page was loaded. We want to know which product ID was used so that we could, for example, reach out to a backend API and a database to fetch the data for that specific product and display it on the screen. And of course, that's also a common scenario, and therefore React Router DOM gives us another tool for getting hold of the actual value used instead of that placeholder, instead of : product ID. And that tool, which we get from React Router DOM, is the use params hook. This hook gives us a params object, if we call it like this. And this params object is a simple JavaScript object which contains every dynamic path segment we defined in our route definition as a property. So in my case here, I got a property called product ID on this params object because in my route definition, I chose product ID as an identifier for this placeholder, for this path parameter, for this dynamic path segment. So the part after the colon, that is the identifier which you can use as a property name on that params object here. And therefore, we can, of course, output that ID here below the title maybe. We can output params.productID. Of course, if you chose a different identifier after the colon in your route definition, if you chose just ID, for example, you have to use that identifier here, like this. But here I'll stick to product ID, also here in the route definition. And with that, you will see that now I see ABC here if I'm on /product/ABC. If I visit /products/product-1, I see product-1 here. So that's how we can get hold of that data that's encoded in the URL. And typically you encode things like IDs of items or products in the URL, because then here in product detail, we could reach out to a backend and fetch the data for this product. But that's something we'll do later when we will dive deeper into the data fetching capabilities of React Router DOM. Now, to conclude this introduction to dynamic path segments, there's one last thing I want to do here. I want to add some real links here to my products page. For that, we can, of course, again use the link component from React Router DOM. And here I'm using link instead of navlink because I don't want to highlight those links as being active once they're clicked, because we're actually leaving this page when clicking one of these links here anyways. So therefore here I'll use the regular link and wrap that around my products. So product 1 and of course also product 2 and the same for product 3 like this. And then we add the to prop with the paths we want to navigate to. And here we want to go to /products/product1, for example. Here we want to go to /products/product2, and so on. Now, in reality, you would probably fetch the product data from some backend, from some database. And therefore, you might have your products as an array, which you're getting from your backend. Here, I'm hard coding it in this dummy products constant, but this could be data coming from a backend. The data you might be getting might be an array full of JavaScript objects, where every object has an ID and a title, like product1. So here, I might have 3 products, which are fetched from a backend, which have different IDs and different titles. That's how we might be getting our data. And therefore, in reality, instead of hard coding our list items like this, we might be creating that list dynamically, as you learned it earlier in the course, by mapping through all these products. And then here, we're rendering a list item for every product in this array. We add the key, as we should always do when creating lists like this. And in the list item, we then output our link, where between the link tags, we output the product title. And now the link should be constructed dynamically, the value for the to prop, I mean. And to do that, we could add a dynamic value where we construct a string dynamically by using backticks so that we build such a JavaScript template literal, which makes it easier to dynamically inject dynamic values into this string. And then we start with /products, but thereafter, after this second slash, we inject a dynamic value into this string, and the dynamic value here could be prod.id. So now we're generating multiple list items with different links which have different paths. Now with that, if we save that and we go to /products, we got this list here. But if we click those different links, we're taken to the product details page with the different product IDs, which can also be found here in the URL. So that's how this is connected. Of course, this works for all the products here. So that's how we can generate and build links for routes that have dynamic path parameters. Now, to conclude this basics part about React routing, I want to talk about paths again, which might sound boring, but which is important to understand and get right. When defining our routes, we define the paths for which they should be active. We got this root wrapper route here, and then we got a couple of child routes inside of that route. Now, actually, all the paths I'm defining here are absolute paths because they all start with a slash. This simply means that they're always seen from after the domain name. Now, this is an important detail. If I would, for example, change this wrapper path to /root, you will notice that if I reload for /products, I don't see anything, but neither do I for /root/products. If I type in just /root, I also don't see anything on the screen. And the reason for that is that if I open my developer tools, I got an error that I got the absolute route path slash nested under path /root. So the problem I'm having here is that, as mentioned, we have absolute paths here because they're starting with a slash. That's how you can tell that these are absolute paths. If a path starts with a slash, it is an absolute path. And we now have clashing route definitions. We're saying that the parent route here should handle all pages that start with /root, but then the child pages actually don't start with /root. Now, of course, here it doesn't make sense to start with /root, but it's important to understand the problem here and the difference between absolute paths, as we have them here, and relative paths, because that's the alternative. We can remove those leading slashes here on the child routes, and that turns these route definition paths to relative paths. So now we got 3 relative paths here instead of absolute paths. Now, when defining routes like this simply means that these paths defined here are appended after the path of the wrapper route. So if we have a child route with a relative path, then React Router will take a look at the path of the parent route and append the child route path after the parent route path. So if we make those changes, this error goes away, and for just /root, we see the starting page, and for /root/products, we see the products page. Of course, for just /products, we don't see anything. Instead, we get the default error message again. We also don't see the content of our error page because now we got this error for some page that we tried to find after /nothing, but this error element is added to the /root path. Therefore, it's not activated here. Now, of course, here I don't want to have /root as a starting path. I want to have /nothing instead, but we can still stick to relative paths for these child routes because we want to append these paths after the path of the wrapper parent route here. But that is not all you should know about paths. Instead, paths also play an important role if we think about links, like here in the main navigation or in the products.js file, where we also have links. Here, we're also defining paths, and the same rules as before apply. If a path starts with a slash, with a leading forward slash, then it is an absolute path. So clicking that link will always visit /products. Again, you can see the problem if I do switch back to /root here for my root route temporarily in my route definitions, and I then go to /root/products. This works, but if I click one of these links here, we get an error because those links lead to /products/p1. Why? Because in the products.js file, that is the path we defined here, and since it starts with a forward slash, it's an absolute path, so it's added directly after the domain name, not after the currently active path. But we could switch to the latter behavior and instead create relative paths here on those links. We could, for example, do that in the home.js file by instead of linking to /products, to change this to just products without the slash at the beginning. With that, this is now a relative path, and this link has a relative path now, which means that by default it will add this path after the currently active routes path. So if we go back to just /root and I click the list of products, which is that link I just edited, you see it will lead me to /root/products. And previously it would have failed, as you can see here in the main navigation, where we have absolute paths to routes that we no longer support. And in products.js, we can also switch to a relative path by simply removing that /products/ part. Now we just add the product ID after the currently active route path. And that of course means we can also get rid of this entire template literal part here and just change the path to that. And with that, it's added after the currently active path, and therefore these links work again. So it's really important to understand these differences between relative and absolute paths. And when using the link component, you also have a special relative prop which you can add here. And this can be set to one of two values at the moment, to path or route. With that, you control whether this segment here is added relative to the currently active route path or to the currently active path in the URL. And that might sometimes be the same, but sometimes it's also not. To show you the difference, let me go back to my route definitions here. And there, please note that this route definition, which is responsible for the product details, is a direct child of this root route, not of this products route, but of this root route. It's a sibling to the products route. These two route definitions are siblings. We could have built it differently, but here they are siblings. So for both the products and the products/SOMEID route, the parent route is this route with /root. Now, if on the product detail.js file, we add another paragraph with a link, and therefore I'm importing link from React Router DOM, where I say back, we could implement this behavior by adding the to prop and adding 2 dots. This is a special identifier, which you might know from moving around in your system terminal, which simply means go up one level. Please go back to the previously active path and route. Now with that added here, I'll go back to products.js and remove relative here, because I can show the behavior of this relative prop very well with this link now. We added this to the product detail page. Here, if I now go to a product and I click back, you will notice that I go back to the home page by default. Now this might not make a lot of sense because we came from the products page when we clicked on one of these products. Yet if I click back here, we go back to the home page. And you also see that in the URL when I visit a product is /root/products/the ID of that product. But if I click back, it's just /root. So /products/product ID was removed from the URL path. That happens because we're going back, and by default, this relative path, which this is as well, despite looking strange, but it is a relative path, this relative path is resolved relative to the route definitions. So here, for example, as I mentioned, this product detail page route definition is a child of the root route and a sibling to /products. So when we go up one level, if we go back to the previous route path, it means that we go back to the parent's route path, not to this sibling here. So we don't just remove one segment from the path, but instead we go back to the parent route path, which means we remove 2 segments, in this case, /products and /product ID. Now, if we want to change this behavior, we can do so with the relative prop. We can set this to path. The default would be route, so it's relative to the route definitions, which behaves as I just explained it. But if we set this to path, React Router will instead take a look at the currently active path and simply remove one segment from that path. So now if I click on back here on that product detail page, you see we go back to the products page because now just the ID of that product was removed from the currently active path. And that's another important feature you should keep in mind when working with paths and links and relative versus absolute paths. The relative prop does not matter if you have an absolute path here. Then it's always that absolute path that's added after the domain. But if you have a relative path, like this special two-dot path, which simply goes back, then this relative prop can be used to control the behavior of a React router. And even without that, it is important to be aware that there is a difference between relative and absolute paths, and to keep that difference in mind. With that, I'll change my parent route path here back to just slash instead of slash root. And with that, it of course also all still works as before. But now you learned about the difference of relative and absolute paths and how it matters and why it matters. Now, related to what you learned about relative and absolute paths, at least kind of related, there's one special property you can add to your route definitions, to some route definitions. And that is a special property that would, for example, apply to the homepage here. What's special about this homepage route definition? Well, in the end, it doesn't have a path. Instead, the homepage should be loaded for the same path as we have it here on the parent route. We have two different routes because we want to have that wrapping layout, though. But it is quite common that you might have such a wrapping layout route as we have it here, and then you have one child route that should be loaded for the parent's route path. Now you could solve it like this by adding no path, but alternatively you can add the special index property and set this to true. This turns this route into a so-called index route, which simply means it's the default route that should be displayed if the parent route's path is currently active. So it will not be loaded for products or products/product ID, but if we're on just /nothing in this case, this index route will be activated. And if we save that, we therefore get the same behavior as before, the application works as before, but this is now a different way of solving this, and you should be aware of this feature called index routes, which allows you to define the default route that should be loaded if the parent route's path is active. Of course, you don't have to have index routes. It depends on your use case and application, but often you want such default routes. And that is how you could solve it alternatively to adding this empty path here. At this point, you already learned a lot about routing, and we had a thorough look at all the key routing features you must know. Now, over the next lectures, we're going to dive deeper into routing and explore more advanced routing features, especially related to data fetching and submission. But before we do so, it's time to practice what you learned. Now, for that, you find another project attached, and this project actually includes two project folders, a backend API and a React frontend folder. You also got a file with some instructions, but in the end, this backend API folder simply includes a dummy backend application that does not contain any React code that will be used throughout this course section so that we have a dummy backend to work with. We could also use some public service like Firebase or some public dummy API, but here I built this custom dummy API which we'll use. But you won't have to write any code in this backend API folder. This is provided for you. It's not related to React, and you can of course explore that code, but you don't have to understand it. It's Node Express code, not related to React, but we will be able to send requests to that backend API from inside our React app. Now, very important, in the React frontend folder, you then find the React app on which will work throughout this course section. You will see that there I already added some components which we'll use throughout this section and which you of course can explore. In the end, these are all relatively straightforward components with some default styling provided. And for the rest of this section, as mentioned, we're going to dive deeper into routing with React. Now, one important note right away, you will need to start this backend server and this frontend server independent from each other. So you will need to open your terminal and navigate into the backend API folder, initially run npm install there, and then run npm start to start that backend server and keep that process running as long as you are working on this overall project. You can, of course, then quit it thereafter with Ctrl C, but you should always restart that backend server in the backend API folder whenever you want to go back to working on that React frontend, because that frontend later must be able to talk to that backend, and for that, the backend server must be up and running. And in a separate terminal window, you also must install all the dependencies for the React frontend application initially. And you, of course, also must start the React frontend dev server in order to work on this React application. So both servers, backend and frontend, should be up and running for this course section. And with that, that's the project setup. Now let's dive into these projects. Now, before we're actually going to dive into advanced features, I want you to practice what you learned up to this point, because it is super important that you understand all these routing basics. Therefore, in this React frontend folder, in the source folder, in the app.js file, you find an exercise, a challenge with multiple steps, with multiple tasks that you should complete. And of course, these steps here will require you to use the knowledge you gained over the previous lectures. You will need to install the React router, set up routing, set up some route definitions, add links, and much more. So definitely go through these tasks, these instructions, and then try to solve all these tasks, all these challenges on your own. In the next lecture, we'll of course solve them together, but you definitely should try it on your own first so that you get the most out of this course. By the way, the last step is a bonus task which you can theoretically solve, but which requires you to do something we haven't done before. So don't worry if you're not able to complete this task. You will, of course, also see the solution for that in the next lecture, but definitely feel free to give it a try on your own first. So, did you succeed? Let's now solve all these tasks together. And for this, as a first step, here in my terminal, which is navigated into this React frontend folder, I will install React Router DOM. That's the first thing we must do, because it hasn't been installed here yet, and we do need this package in order to add routing. Now with that, and the development server back up and running, we can now solve these tasks. And I will, of course, start with task number 1, which requires me to add a couple of pages here. And for that, I'll add a brand new folder, the pages folder. And in that folder here, I will add a homepage.js file. And then also my events page, event detail page, new event page, and edit event page. So here I'll add events page, new event page, event detail.js, and edit event.js. And actually, I'll remove the word page from the file names. We could also leave it there, but since the folder is already named pages, I'll omit page from the file name. But with that, I got these page files which are requested, and I can now add my homepage component function in the home.js file, and of course also export that component function here. And for the content, I'll just return a dummy h1 element, as was requested here in the task description, because for the moment the actual content isn't too important. That is something we will work on throughout the discourse section, but for a start, I'll just output this h1 title with a text of homepage. And I'll then copy that and add that to the events.js file and rename this to events page, also here for the export and for the h1 tag. And then repeat the same for all the other page files. So here we got event detail, and I'll also replace that here and here. And then here I got the edit event page. And of course, that's then also replaced in all these places. And the same will be done for new event. It's the new event page, like this. So now we added all these page components, and that's task number 1 solved. Now for the next task. Here we now should add routing and the route definitions so that we can theoretically load these different pages. And for that, I will now import something from React Router DOM. I will import from React Router DOM, and I will import 2 things. The first thing is the router provider component, which will be needed to apply and activate our route definitions, but that's then of course the other thing that must be imported, the function that allows us to create these route definitions. And that's the create browser router function. With these 2 imports added, we can create our router here by calling create browser router. And now it's up to you whether you also want to use the create routes from elements function and use these JSX elements to define your routes, or if you want to pass an array to create browser router and then use these objects here to define the routes. I'll do the latter. And I'll start with a route for my root route for /nothing, where the element is the home page, because that is the page that should be loaded if we are on our domain /nothing. For that, of course, the home page also must be imported. And then we can add another route here, which is /events. And these are the paths that are specified here in the task descriptions. So for /events, we should load the events page. And therefore, of course, here I add my element events page like this. And then I add all the other required routes, like for example, events. And then we want to have a route that supports basically all kinds of IDs and should then load the event detail page for these different IDs. So we need a route where the path contains a parameter, where we have a dynamic path segment. And you learned how that can be defined. We add a colon and then any identifier of our choice, like for example, event ID. And then here the element is event detail page, like that. Now the next path which I want to add is /events/new. So therefore here I add /events/new and the element is new event page. Now, one small side note here. If you watch closely, you might actually see and think that if we have a path of /events/new and we have a path of /events something, this route here might actually never get activated because new could also be treated or seen as a value for the event ID here. So whenever we enter /events/new in the URL bar, React Router could actually load this route instead of this route because it treats new as a value for event ID. And therefore this route would never get activated. This could happen in theory, but actually React Router is smart and understands that this route path is more specific than this route path. So indeed, if you would visit /events/new, it would prefer this route definition over this route definition. And that's just something to be aware of, that you don't need to worry about accidentally overriding this route definition, and that you don't need to worry about the order of route definitions. This route here, /events/new, will win over this route. But that's just a side note. So now the last route definition which I want to add is this definition, where we want to load the edit event page if we are on /events, then some ID /edit. The path, therefore, is /events, then again my dynamic segment, and then edit. This is something we didn't do before, but it is absolutely a path you can add to your route definitions. You can have another hard-coded segment after a dynamic segment. That is allowed and possible. So here we then want to load the edit event page. With that, we got these route definitions. Now we can render the router provider component and set the router prop to our router object that contains these route definitions. And with that, we should be able to visit these different pages. If we go back, we start on the home page. If we type in /events, we see the events page. If I type in events/E1, for example, which could be an event ID, I see the event detail page. If I add /edit thereafter, I see the edit event page. And if I replace E1 with new, I see the new event page. So this is all working, and we are able to reach all these different pages. And with that, we also solved this second step here, this second task. Now, the next step is to add a route layout that adds the main navigation component, which I provided to you, which is already part of this components folder, around all pages in the end. And that can be done by adding a special new route, which will be a parent route for all other routes. For that, I give it a path of /nothing. And then here, I want to render an element, which is a route I have yet to add, a page I have yet to add. And I'll name it route.js again. And this is again my route layout, or however you want to name it, which of course is exported like this. And then here in this route layout component, I will have my JSX fragments here. We could of course also use React fragment here as an alternative, but I'll use these empty tags here, which is a bit shorter. And then here I have my main navigation, which must be imported. And below that, I'll actually wrap it in the main element, but that's optional. But what's not optional is that below that, or inside of the main element, I will render my outlet, which must be imported from React Router DOM. So I'm importing outlet from React Router DOM. And as you learned, this defines where the content of the child routes should be rendered. So with that route layout component function defined, we can go back to app.js, and here it's this route layout that is rendered for this route. And now all the other routes should become children of this route route. So we can move all these routes into this route route so that they will benefit from this route layout. And if we do that, we'll see now we got this navigation here. It doesn't work yet, but we can see this navigation at least. Now, a quick note about these paths. As you learned, it could matter whether they are absolute or relative. And therefore here I'll actually convert them all to relative paths so that they are relative to the path defined in the parent route here in the route definitions. And I'll actually turn this first route here for the home page into my index route instead of defining this empty path, which is also something you learned about in the previous lectures. With that, we added all these steps, all these imports, and now we have the same result as before, but we can now continue with the next steps. We finished step number 3. The fourth step is that we should add properly working links to main navigation. So to this main navigation.js file. And here indeed at the moment I just have some anchor elements that don't do anything. Now as you learned before, what we want to do instead is we want to import the link component from React Router DOM if we want to construct a link instead of using the anchor element. So we want to use that here instead of the anchor elements. And then on those links, we have to add the toProp to define where those links should lead to. The home link should lead to /nothing, and I'm deliberately using an absolute path here because it should always lead back to that starting page and not add anything after the path of the currently active route. That's not what should happen. Instead, it should always go back to the starting page. And here, for the same reason, I always want to go to /events, not add anything after the currently active path, but instead always go back to /events. And with that, we added those links, and we can therefore now switch between our pages with those links in the main navigation. The styling, by the way, is still off, but that is something we can ignore for now because we'll change the styling and the content later throughout this section. Now that was the fourth step. The fifth step actually builds up on the fourth step because now we should adjust those links in the main navigation such that they reflect whether a link is currently active or not. So whether a link was responsible for the currently active page or not. And we of course also learned how that works. We have to use the special navlink component instead of the regular link component. Navlink is also imported from React Router DOM. And we still add the toProp, but now we can add the class name. And we could have added that to link as well, but with navlink, class name receives a function which gets an object automatically provided by React Router, where we can get the isActiveProp with help of destructuring, which is what I'm doing here. And then we can use this isActiveProp to dynamically add the active class, which is defined in this main navigation.module CSS file, and otherwise alternatively use undefined or render undefined. And then we can also add class name here for my events link. And with that, we actually do highlight the active link, but we have a problem which we also encountered before already, that the home link is always active. Now, I explained before that this happens because actually React Router checks for the start of the path, and we can override that by adding end here, the end prop on this home nav link. This ensures that this link is only treated as active if the currently active route ends with this path. With that, home is active if we are on the home page, but not if we are on the events page. And that's therefore the next step completed. We solved task number 5. Now for step number 6, we should now output a list of dummy events on the events page, and every list item should include a link to the event detail page. Of course, with a different ID. That's important because we do have that dynamic ID in our path that leads to the event detail page. So to do that, I'll go to the events page here and simply add some dummy events. Later in this module, we'll have more realistic data, but here I'll just have this local dummy array. And every event has an ID, let's say E1, and maybe a title of some event. Again, we'll have slightly different data later. For the moment, this will do. And I'll add a second event here. Another event. Now here on the events page, I now want to display this list of events, and for that we can add an unordered list, and then again map through the dummy events, and every event should then be turned into a list item where we set the key to event.id, and where inside the list item we then have a link which must be imported from React Router DOM, of course. So we import link from React Router DOM like this. And then that link should actually lead to /events/the ID of the event for which we're creating this list item. So therefore we could construct the link like this, /events, and then inject event.id. Or we convert it to a relative link by just navigating to event ID. And this will be appended after the currently active routes path. And that is what I want to do here for these links on this page. And here between the link tags, I can then output the event title. So this will now render a list of events, and we can see this on the events page. And if we click on one of these, we are forwarded to the event detail page. Now that is task number 6 solved. And in task number 7, we now want to output the ID of the selected event on the event detail page. And that, of course, is also something we learned about before. We can use another feature from React Router DOM. And that other feature is a special hook, the useParams hook. This hook, when called in a component function, gives us access to the currently active route parameters, so to the values that are encoded in the URL for our dynamic path segments. So for the value that's used here for event ID in this case. We can use this to output this event ID value on this page, just as we did it before, by adding a paragraph where I say event ID, and then I output params.eventID. And it's .eventID here in my case because I used event ID as an identifier after the colon. If you used another value here, like ID or event or whatever, you would have to use that other identifier for getting hold of the value with that params object. But with that, we can see that I see the event ID E1 or E2, depending on which event I click on. So that is the next task solved. That was task number 7. Now the last task here is this bonus task where we can add a nested layout route that adds the event navigation component, which already exists in the components folder, this component here, as a wrapper around all the routes that start with /events in their paths. So around all these routes in the end. Well, and even though we haven't done that yet, it's actually not too difficult. We just add a new route definition where the path is events. Not /events, but events because it is nested in this root route and I want to have a relative to this parent route path. Then here, the element is a new page, which we have yet to add, which is the events root. So here we have the events root layout component. That is how we could name it. And we export that, of course. And this component is very similar to the root layout component we created before. It's actually almost exactly the same. I just want to return 2 JSX elements. And the first one is the events navigation, which is imported from the appropriate file. And below that, I have my outlet. And that outlet component is imported from React Router DOM. And I'm rendering the outlet component here because I want to use this events root layout component as a wrapper around other pages where the content of those pages should be rendered in this place where I have this outlet component as a marker, so to say. And now in app.js, I can use this events root layout component, which we just added, and add this children property to this newly added route definition. And now all these paths, all these routes that should benefit from this newly added layout are moved into this children array. And now we just have to adjust their paths so that it's not /events/events, but instead /events/nothing, /events event ID, /events new, and /events event ID /added. So we have a couple of relative paths here, and now the overall path is constructed from the combination of /events and then whatever path we have down here. And of course, this first route here can again be turned into a index route, now an index route for this events parent route. With that done, all these events routes have this new event-specific navigation here, which doesn't work yet, but which was added because we included this events navigation. And I'm aware that this doesn't look too fancy yet. Again, we'll tweak that overall look and feel and the content of these pages throughout this course section. So now with this events navigation added in this events root layout as a nested layout route that wraps all these event-specific routes, I just want to fix the links in the events navigation JS file. And I will again do this by importing navlink from React Router DOM and replace this anchor element with navlink, also here for the closing tag, of course. And then here we have 2 /events and 2/events new. And now I just also want to add my class name here, where I get this isActiveProp with destructuring, and where I will check if it's true. And if it is, I will add classes.active and otherwise undefined. And I will do the same here for the new event. I will also add the end prop here to the first nav link so that this is not active if we are on /events new, but only if we are on just /events. With that, we also got some active styling here, and we can navigate between these pages. Now, this was a bonus task, and it's no problem if you were not able to solve it, because this is all totally new, but I hope it makes sense. And with that, we now did solve it together. We got all these challenges, all these tasks here completed and solved. And now we're ready to dive into some brand new, more advanced features. We're now ready to dive deeper into routing and explore more advanced features of React Router. And one of the most important feature sets offered by React Router is related to data fetching and submission, and that's therefore what we'll explore next. For that, attached you find a new file, events.js, which you should use to replace your events.js file in the pages folder with it. And once you replaced your events.js file with the provided one, and you then explore this events.js file, you will see that in that file there is some code that sends an HTTP request to that dummy backend API, which I'm providing to you. And you should make sure that that backend API server is up and running in a separate terminal window, as shown a couple of lectures ago. And then that response is evaluated. An error is stored with help of state if it's an invalid response, for example, because we got an error back from the backend. If we don't have an error, we instead extract the data from the response and store that with help of state as well. And we're also managing the loading state, and then all these states are used down here to either show a loading text, an error message, or to render the fetched events, which are now fetched from that dummy backend, some dummy event data from that backend. Those events are rendered here with help of that events list component, which exists in this components folder already, so which was part of that starting project I provided earlier. And this code should look familiar to you. Throughout this course, you already learned how you can send HTTP requests to a backend and how you can leverage useEffect to fetch data from a backend. So this should be familiar code here. Now, there is nothing wrong with that code, but of course it is worth noting that it's quite some boilerplate code which you have to repeat every time you're sending a request to a backend. Though you could kind of mitigate that by creating a custom hook, and you could outsource that logic into a custom hook. But nonetheless, it's quite some code that must be written to handle these different HTTP request states and to fetch that data. And in addition, what's also worth noting is that, of course, this request will only be sent once we reached this page, so once we navigated to this page. This is, by the way, how it looks like. This is the data fetched from this dummy backend. So we only start sending that request as soon as we reach the events page. We don't start sending the request any earlier, instead only once we reach this page. And that, of course, means that this entire events page component must be rendered before this request is sent. That's not necessarily a problem, and here it is a pretty straightforward, simple component. But of course, in more complex applications, this component could be rather complex, and it could also have a bunch of nested child components, and having to render and evaluate all these components before we actually start sending that request for that data which we absolutely need is suboptimal. You could argue that it would be much nicer if React Router would initiate the data fetching as soon as we start navigating to this page. So as soon as we start rendering this component, so to say, or even before we render the component. And we then render that component with the fetched data, instead of first rendering the component without the fetched data, with the loading state fallback instead, and then fetching data after it has been rendered, as it's currently happening. It could be preferable to do it the other way around and first fetch the data and then render this component. And that's exactly what React Router allows us to do, and where React Router helps us. With React Router, at least if you're using version 6 or higher, you don't have to write all that code for fetching data and for handling these different states. Instead, React Router helps you with all of that. And it helps you with all of that by giving you an extra property which you can add to your route definitions. Now, we're currently talking about this events page. That's this page where we're fetching data. And in our route definitions, we can add an extra property to that route definition of that page. We can add the extra loader property. Now, loader is a property that wants a function as a value. A regular function or an error function, that does not matter. And this function will be executed by React Router whenever you're about to visit this route. So just before this route gets rendered, just before this JSX code gets rendered, this loader function will be triggered and executed by React Router. And it's in this loader function where you can therefore load and fetch your data. So we can go back to events.js and grab this code where we fetch the data and where we evaluate the response, and cut that and instead move it into this loader function. Now, we will need to tweak this a little bit to make the code work though. For example, we should add the async keyword here so that we can use the await keyword. Alternatively, we could of course add the then method here, since fetch returns a promise, but async await is a bit easier to read. We also don't need to set any state values here, so we get rid of all of that. Instead here, we'll deal with that incorrect response case later, and we'll focus on the scenario that we do have a valid response. In that case, we got the response data in this loader function, and of course we want to get that data to that events page component, because that's where we need the data. Well, the great thing is that when you define such a loader function, React Router will automatically take any value you return in that function, for example, the response data, and will make that data available in that page that's being rendered here, as well as any other components where you need it. And I will show you how to get access to that data in a couple of seconds. So we return res data here. To be precise, I want to return res data.events because my response data object is actually an object that will have an events property, which holds the actual array of events. That's simply how the backend API returns the response for this request. So we must access .events here to get that array of dummy events from the backend. And with that, this data is made available to the events page and any other components that need the data. So how can we now access that data then? So how do we now get access to that data returned by our loader? Well, for that we have to go to the component where we want to use it, like for example, the events page component. There, as a first step, I can get rid of all that remaining code which we had in there before, all that state management and use effect, and get rid of this div here, which shows my loading and error states. We will see how we can implement those states again in the near future, but for the moment we can get rid of that. Of course, we also get rid of these checks here, therefore, and just return events list like that. And we can get rid of these imports. And now to get access to the data returned by the loader function for this page, we can import use loader data from React Router DOM. This is a special hook which we can execute to get access to the closest loader data. And I will show you what closest loader data means in just a second. So here, I now get my data by calling useLoaderData. We could also name it events, since we know that it will be a list of events in case of this component here, due to the code we wrote in this loader. And events here will really be that data returned by that loader. Now, since I'm using async await, technically, this loader function will return a promise. Any data returned in that function will be wrapped by a promise. That's how async await works. But React Router will actually check if a promise is returned and automatically get the resolved data from that promise for you. So you don't need to worry about whether you're returning a promise here or not. You will always get the final data that would be yielded by the promise with help of useLoaderData. And therefore now it's this events object, this array of events, which we can pass as a value to this events prop on events list. If we save that all, you will see that we got the same result as before. We got this list of events, in this case only one event, but if we had multiple events returned by the backend, we would see multiple events here. And we got this all due to the code we wrote in this loader. And of course, that's much less code than what we had before, and it's also not part of the component function, which makes the component function way leaner and easier to reason about. Of course, we're also not managing any loading or error state yet, but nonetheless, we got a way leaner events page component, and that's definitely a decent improvement over what we had before. Now, before we dive deeper into this entire loader thing and also talk about error handling and so on, let's see where else we could use this useLoaderData hook. We can use it in this page, which is rendered by the route on which we added the loader. But where else can we use it? Well, we could also use it directly inside the events list component. So instead of using it here, and instead of importing it here, we could go to this events list component and use this hook there. Here we can also import useLoaderData from React Router DOM and then call this in this component, even though it's not a page component. But there technically is no difference between page components and other components, so therefore we can use it here as well. And if we do that, you will see that this events object, which we're getting here, will be available and everything will work. I just need to make sure that I'm no longer waiting for events props here, which I try to destructure. But if I remove those props here, you will see everything works, and I am fetching and rendering those events successfully. So that works. Now, one place where we can't get those events is in a higher level route. So for example, if we would go to the root layout here, which is part of my root route. If I go to this root layout and I use loader data here by first of all importing use loader data and then calling that hook here, you will see that if I try to get my events here and I console log my events, this will not work as expected. Instead, it logs undefined. The reason for that is that I'm trying to get data from a route that's actually defined on a lower level. I'm trying to get data that's loaded from this route in this root route, which is on a much higher level. After all, this is a deeply nested route, and that's not possible. Instead, you can access loaded data with help of useLoaderData in any component on the same level or lower level than the component where you added the loader, so the route on which you added the loader. So that is simply how that works and what you should keep in mind. With that, I will actually change my code again and use loader data in the events page component and bring back that events property on which I pass my events to events list. And I will get rid of my loader data usage here in events list and instead bring back this object destructuring here in my parameter list to extract the events from my props. With that, it again all works, but now with that original approach where I use loader data in my page component, ultimately it's up to you. You just have to be careful that you're not accidentally using use loader data on a higher level than you're fetching the data. So we added our loader here. You could argue that whilst this did improve our component, it actually made this app.js file a bit more bloated. And especially if we would add more loaders to more and more routes, this file would start doing a lot of things. You could also argue that the logic for fetching data for the events page belongs to the events page and not to the app.js file. So you might want to put that code into the events page file and not into the app.js file. And for those reasons, a common pattern and a recommendation, if you want to call it like that, is that you do actually put that loader code here into your component file where you need it. So to the page component file where you want to add the loader, to be precise. In this case, that's the events.js file in the pages folder. And here we can simply export a function which we could name loader, though that name is up to you. It does not have to be loader. And you put your code, your loader code, into that function. I'll actually turn it into an async function here because I'm using the async await keywords. And with that, that loader code is in that function. Now back in app.js, we can simply import that loader here and give it an alias like events loader. Of course, that name is also up to you. And that, of course, is simply a pointer at that function which we define and export here in events.js. Therefore, in app.js, we can use events loader, which is that pointer at that function, and use that as a value for this loader property here. And with that, app.js is leaner again and doesn't contain the actual data fetching logic. And at the same time, the events page component is also still lean because we outsourced that code in a separate function, which is now closer to the component where it's actually needed though. And that is arguably the best of both worlds and how you should typically structure this. Okay, so we got started with those loaders. Before diving deeper, I want to clarify when exactly that loader is executed. And I actually already mentioned it before. The loader for a page will be called right when we start navigating to that page. So not after the page component has been rendered, but before we actually go there. And you can see that that's the case if you go to the backend API and there to routes, events.js, and here, this very first route, that's the code, the backend code that's responsible for returning data to the frontend. We don't fully need to understand it, but what we can do here between this const events line and the rest JSON line is that we add a timeout. And here we could set a timeout of, let's say, 1.5 seconds and move that rest JSON code into the timeout callback function. Now, this will simply ensure that the response is only sent back from the backend to the frontend after 1.5 seconds. And I'm introducing this delay here to show you how this is reflected on the frontend. If we now go to the terminal where we started the backend server and we quit that server and restart it, since we changed our backend code, I can go back, go to the homepage and click on events. And you will see that at first nothing happens, and only after 1.5 seconds we go there. So here I click, and now we wait, and now we go there. Because the data fetching is initiated as soon as we initiate the route transition, but by default, React Router will actually wait for the data to be fetched, so for the loader to be finished, before it then renders the page with the fetched data. The advantage of this approach is that you can rely on the data being there once the events page component is being rendered. You don't need to worry about whether the data is there yet or not, and therefore you don't need to render a loading state on this events page component. The downside, of course, is that we have this delay where it looks to the user as if nothing is happening. And we'll see how we can improve this user experience in a couple of seconds, and actually also later again towards the end of the section, because React Router gives us various tools for improving that user experience. But that's how data fetching generally works. Now let's take a look at the first option React Router gives us for giving the user some feedback that something's happening here. So how could we give the user some feedback that something's going on here after clicking on events? Well, React Router gives us a special hook which we can use to check the current route transition's state. So to find out if a transition has been initiated and we're currently still waiting for data to arrive, or if we're done. Now we could go to the route layout component, and there we can use the use navigation hook, which is a hook provided by React Router that lets us find out whether we're currently in an active transition, if we're loading data, or if we have no active transition going on. We get a navigation object when we call use navigation, and that navigation object has a couple of properties, but for us the state property is the most important one. This is simply a string which is either idle, loading, or submitting, depending on whether we don't have any active route transition, if we're having an active transition and we're loading data, or if we're submitting data, which is something we'll take a look at later. With that, we could add a loading text here in our main section, for example, which is only shown if navigation.state is equal to loading, like this. With that added, if we go to home and back to events, you see that loading text here, which signals to the user that we are loading data. So which gives the user some feedback that something is happening. And this happens every time we go to this all events page. Now, of course, the styling is not perfect here. It might be nicer to add a little loading bar at the top or anything like this, but that is how it theoretically works. Now, I'm going to get rid of it here because we'll actually learn about a different solution later in this section, but this is one way of finding out whether you're currently waiting for data or not, and how you could bring back such a loading indicator. It's just important to recognize that the loading indicator won't be added on the page which you're transitioning to, but instead on some page or component which is already visible on the screen when the transition is started. That's different compared to what we had before with useEffect and a separate loading state. Now with all that done though, I will go back and remove this timeout here on the backend and move back to the code we had originally on that backend, because I now no longer want to simulate this. Therefore, I also restart the backend server, and we can now dive back into the frontend code. Now, I want to dive back into the loader here. It's an important feature of React Router, and when using React Router, you will use loaders and another feature we'll dive in later for fetching and sending data. So it's important to understand this. Now, one important aspect of a loader is to understand that you can return any kind of data in that loader. Here, I'm returning this events property, or the value stored in the events property of my response data, and in this case, it will actually be an array that I return. But we could return a number, some text, an object, whatever you want. And what you can also return is a response object. Now, what do I mean by that, though? Well, in the browser, you can create a new response object, which I'll name res here, by instantiating the built-in response constructor function. Now, this is built into the browser. This is a modern browser feature. You can build your own responses. And what's really important to understand at this point is that this loader code will not execute on a server. This is still all happening in the browser here. Even though it's not in a component, it's still in the browser. This is still client-side code. That's really important. Nonetheless, we can create a response here because the browser supports this response constructor and response object. Now, this response constructor also takes any data of your choice as a first argument. And then you can configure it with greater detail with help of an extra object that can be set as a second argument. For example, you could set the status code of your response here. Now, whenever you return such a response in your loaders, the React Router package will automatically extract the data from your response when using useLoaderData. So the data returned by useLoaderData will still be the response data that was part of the response you returned in your loader. Now that might not seem too useful here, because why would we create a separate response object if we can just return the data like this? This is way shorter, right? Well, yes it is, but this feature exists because it's quite common that in this loader function, you reach out to some backend with the browser's built-in fetch function. And this fetch function actually returns a promise that resolves to a response. Now, combined with React Router's support for these response objects and its automatic data extraction, that simply means that you can, in the end, take that response, which you get here, so this response object, and return that in your loader. You don't need to manually extract the data from the response. Instead, you can return your response like this, with or without checking whether it's okay. That is up to you, and I'll get back to error handling in a couple of minutes. But we can't just return the response like this, and useLoaderData will then automatically give us the data that's part of the response. Now I just have to make sure that I do extract my events from that data object which I get here, because that is actually an object with an events key, just as I extracted events from the response data in my loader a couple of seconds ago. But with that, we can reduce our loader code and leverage this built-in support for response objects, and that's why I also wanted to mention that this special kind of return object is supported by React Router and its loader functions. Okay, we spent quite some time on this loader function, but it is an important concept to understand. Before we now finally take a look at error handling with loaders, there's one last thing I really want you to keep in mind. This might look like backend code. It might look like it's decoupled from the React application, and it kind of is. But as mentioned before, this code that's defined in the loader executes in the browser, not on some server. And I'm highlighting this because that of course means that you can use any browser APIs in your loader functions. You can, for example, access local storage here, you can access cookies here, you can do anything you can do in the other JavaScript code as well. What you can't do in your loader function is, for example, use React hooks like useState. That does not work because those hooks are only available in React components, and the loader function is not a React component. But that's the only limitation. Any other default browser features can be used in loader functions. Now let's move on to error handling, because of course fetching the data could go wrong, and previously, when using this use-effect-based solution, we handled errors manually. Now we're not handling errors anymore. So how can we handle them? Well, for example here, when we see that the response is not okay, if it has a 400-ish or 500-ish status code, what we can do in that case is we can return a different response, for example, or just return an object. Doesn't have to be a response, as you learned, where we could add a isError key and a message, like could not fetch events. So now we return this data package instead of the response returned by our API request here. In our component code, we could now simply check if data.isError, so if this error property, which we set here, exists and is truthy. And if that's the case, we could return a paragraph where we output data.message. So where we output that data message. With that, we still have a pretty lean component. We only added this code here. And we have the error generation and handling code in our loader where it belongs, arguably. If I now deliberately break this code by sending the request to a path that doesn't exist on the backend, you will see that I get this error message here. Again, styling is a bit off, but we could of course change this. So that's one way of handling errors, simply returning data that indicates that we have an error and then using that data appropriately in the component. Now I'll comment this out though, because that's not how I'll do it here, because there is an alternative. As an alternative to returning this data here to the component, we could throw an error. For this, we can construct a new error object with the built-in error constructor, or we throw any other kind of object as an error. And here we could then also, for example, include a message and say could not fetch events, like that. Now, when an error gets thrown in a loader, something special happens. React Router will simply render the closest error element. And you might remember, we covered error elements earlier in this section when we added an error element to the root route to have a fallback page that would be displayed in case of 404 errors. So if we navigated to paths that aren't supported. Well, turns out that error element is not just there to show a fallback page in case of invalid route paths. That is one use case, but not the only one. Instead, the error element will be shown to the screen whenever an error is generated in any route-related code, including loaders. So therefore, what we can do is we can add an error page again, here with pages, and create our error page component in there and export this. And then here we can, of course, output a message like an error occurred for a start. Now we can go back to app.js and add error element here on this root route and render our error page like that. For that, of course, error page must be imported, and then it's added here with error element on that root path. With that, this error page will be displayed whenever we basically have any kind of error anywhere in our routes. Because even though I'm throwing an error here in the loader of the events page, so in this route here, which is a deeply nested route, errors will bubble up. We could add error element to this route as well, and in that case, this error element would be rendered if this loader threw an error. But we can also just have this root level error element, and the error would bubble up until it reaches that route. So with that, if we save this, you see that we get an error occurred once we visit /events. And we get the same page if we try to visit an invalid route, by the way. Of course, the other routes still work, but trying to visit events gives us this error. Now, of course, this error page here isn't too beautiful and too helpful. And therefore, to improve it a little bit, as a first step, you find a new component attached to this lecture. And that's the pagecontent.js file. It's a little helper component that provides some styling, which I'll use to render it here on this error page. For that, we must import page content from, and then components, page content. And here we can set a title property and set it to an error occurred. We can then also pass some content between the opening and closing tags of page content, and for example, add a paragraph where we say something went wrong. Now this looks a bit nicer, but we can still improve it. For example, we might want to differentiate between 404 errors and other errors like the one we have here from our loader, where we actually have an error message that we might want to display instead of the default error message I define here. So to differentiate between errors, what we can do is instead of throwing an object, we can throw a response by again creating a new response, and then we can include some data into that response. For this, we have to call JSON stringify if we want to pass an object to the response. And then we could add a message prop and say could not fetch events. And now we can add this second argument to the response constructor and set the status, for example, to 500 to indicate that something went wrong on the backend. That's just one example. In this case, it's an incorrect URL, but we could set this status code. Now I'm doing this because you can actually get hold of the data that's being thrown as an error inside of the component that's being rendered as an error element. And for that, React Router DOM gives you another special hook, which we import from React Router DOM. And that's the use route error hook. This gives us an error object, if you want to call it like this. And the shape of that object now depends on whether you threw a response or any other kind of object or data. If you threw a response, as I'm doing it here now, this error object will include a status field, which actually reflects the status of the response you threw. In my case, that would be 500 because that's the status I set here. If you threw any other kind of object, like a regular JavaScript object, then this error object would already be that thrown object. So then there would not be this special status property. But that's why you might want to throw responses instead of regular objects, because it does allow you to include this extra status property, this extra status field, which helps with building a generic error handling component. Because now in error.js, in this error page, we can create our title and our message and set these to default values, but override them with more fitting values based on which error we have. So we could, for example, have these default values here, but then we can check if error.status is maybe 500, in which case we might want to keep the title, but set the message to error.data.message. Now error.data gives us access to the data that's included in this error response that was thrown, so to this object here in my case. And that object has a message, and we can assume that most objects that are included in error responses will have message properties. That's why I'm accessing the data object of the error response and then the message property here. But we could, for example, also check if the error status is maybe 404, which is the default status set by React Router if you enter a path that's not supported. And in that case, we could set the title to not found and the message to could not find resource or page. And now we can use these values down here and set the title to our title, which we set conditionally, and also output our message here, which is set to different values based on different status codes. With that, there's just one last thing. This data object here actually, first of all, must be converted back to an object, because otherwise it's still JSON in JSON format. So we must use JSON parse here, and then access message on the parse data. But with that done, you see I got this error output in case of my error due to me visiting events. And if I enter an invalid URL instead, I get this not found page. It's always the same component, but now with this generic error handling code. And that's why we might want to throw responses in the places where things go wrong and add such a generic error handling page, which is rendered with help of an error element added to the root route. That's one way of handling errors and embracing those features that are built into React Router. Of course, we could now improve this error page even more by maybe also adding our main navigation here. With that added, we now have a way of going somewhere else after we triggered an error. So that might be a better user experience than having this full screen error page. With that though, I'll go back to events.js and fix this path so that we can fetch events successfully again. Now, when using React Router, you will from time to time construct responses as we're doing it here, especially when it comes to throwing errors, for all the reasons mentioned in the previous lectures. Now, constructing responses manually like this is possible, but a bit annoying. That's why React Router gives you a little helper utility. Instead of creating your response like this and returning it like this, you can return the result of calling JSON, written like this. And JSON is a function that can be imported from React Router DOM. Now, JSON is a function that creates a response object that includes data in the JSON format. To this JSON function, you simply pass your data that should be included in the response, in my case, my object. And you don't need to convert it to JSON manually. Instead, that will be done for you. And you can pass a second argument where you can set that extra response metadata like the status. And here I set the status to 500 again. Now with this JSON function, you don't just have to type less code here, but in the place where you use that response data, you also don't have to parse the JSON format manually. Instead, you can simplify the code to this because the parsing will now be done by React Router for you. And therefore now here, if we break this again by sending the request to an invalid URL in this loader, you see we got the same error message as before, but now with less code to be written from our side. And that, of course, is a great simplification, and hence it is quite common to use this JSON function for building responses with less effort. With that, I'll again fix this URL here so that we do fetch events successfully again, but you should keep this JSON function in mind. Okay, let's proceed with this demo website here. We got our list of events. Now, if we click on an event, we might want to load the data for that event. And we want to make sure that we go to a valid page to begin with. Now we want to navigate to this event detail page. For that, I'll start by going to events list. And there, we first of all want to convert this anchor element to a link and import link from React Router DOM, of course. And also convert the closing tag to a link. And then here we want to add a path, of course, and we want to make sure that we go to that event ID. So here I have a relative path relative to the path of the currently active route. And that means, if we take a look at app.js again, that if we are on the events page and we append the event ID at the end, we go to this event detail page, because that route is a child route of this events route. So this event ID is appended to this events path here in our route definitions. So we will go to the event detail page if we set up our links like this, and we append the event ID to the currently active path when this events list is being rendered. So that should work. With that change made, if we click on such an event, we go to the event detail page. Now on this event detail page here, I want to output the event item here, a component which I predefined for you and for which I already added some styling. So in event detail, instead of showing this dummy content here, we want to output the event item component. And here we must set the event prop and pass the event data for the event for which we want to view the details to this event prop. And that, of course, means that we need to load the event details as a first step. Now we could do this here in the component by using the params and using useEffect to send a HTTP request, but I won't do this here. Instead, I will add another loader function here and export it. Now this time a loader function for my event details. So I export this, I will convert it to an async function because I want to use the await keyword in here. And now to fetch the data for a single event, we can use the built-in fetch function and send a request to our dummy backend API server, which we can reach under HTTP localhost 8080 and then /events, and then the ID of the event for which we want to load data. But how do we get that ID here in the loader? In the event detail page, we could use the use params hook, but we can't use this in the loader, as mentioned before. Hooks can't be accessed there. But you still can get access to the route parameters that you need, because React Router, which calls this loader function for you, actually passes an object to this loader function when executing it for you, and that object contains two important pieces of data: a request property, which contains a request object, and a params property, which contains an object with all your route parameters. Now, the request object here in a loader could be used to access the URL to, for example, extract query parameters or anything like that. But here we don't need it. Instead, it's the params object which is interesting for us here, because with that we can get access to all the route parameter values as we could do it with help of use params. So here we have the event ID route parameter, we have this dynamic segment, therefore here we can access params.eventID. And that gives us this ID, which we want to add here at the end of this URL to send a request to localhost 8080/events/ the ID of the event for which we want to fetch the details. We then get a response by awaiting this fetch call here. And now we could again return this response here as we learned before. We can return such a response object in our loader. And if that's all we want to do, we could therefore even return it like this. And as mentioned, React Router would automatically wait for the promise and give us access to the data to which it resolves. Here, however, I will first of all await this, because I still want to check if not response okay. So if we have a 400-ish or 500-ish error code, and only if that's not the case, so if we have a successful response, only in that case I want to return the response. Otherwise, just as before, I want to throw an error by using the built-in JSON function, which is provided by React Router. And I will throw an error response where I say, could not fetch details for selected event. And I will add this metadata object here and set the status to 500 again. Now, you could have more granular error handling, but that's good enough for this demo. So with that, we added the loader code. Now we must register the loader in our route definitions. And that's super easy to forget, but it's super important. Just adding a loader function to your component file like this won't do anything. React Router will not look for loaders automatically. Instead, you have to register it here when defining your routes. We have to add the loader property to the event detail page route, and then import the loader here from event detail. And I will again give it an alias so that we don't have any name clashes. And here it's the event detail loader, like that. And that is then set as a value for the loader property of this route definition. With that, the loader will now be called whenever we try to visit this event detail page. And therefore here we can now use the useLoaderData hook to get hold of that data. So of that event detail data. And with that, we can then use this data object to access the event property, because I know that my backend API will include the actual event data for the loaded event in an event property on that overall response data object. So with data.event, I access that event data and I pass that as a value to the event prop on event item. So now if we save everything, if we save all files, you see that I can visit a single event and view the details here. Now, before we start looking at adding events and sending data, there's one last aspect of loading data which I want to touch on here. When viewing the details of an event, we can click this Edit button here at the bottom. And this button or this link should take us to the Edit Event page here. Now for this to happen, I first of all have to go to the event item.js file. And here we want to use the link component provided by React Router. So we have to import that and use that instead of this anchor element here. And then I want to add edit and append that to the currently active route. And of course, this should be to instead of ref. With that, if we do that and click, we're taken to that edit event page. Now on this edit event page, I want to show this event form here. Now we'll tweak that form a little bit later, but for a start, I want to show it, and therefore here on edit event page, I will output this event form here. And this event form component, of course, also must be imported. Import event form from components event form. So that shows us this event form here. Of course, that event form should be pre-populated with the data for the event which we're trying to edit here. Now to do that, we need to fetch that event detail data, not just on the event detail page, but also here on the edit event page, because that's where we need the data for the event form. So in this edit event page, we need to fetch the same data as we fetch here on the event detail page. These are two different route definitions, event detail versus edit event page, and therefore two separate loaders would be needed. But actually, thankfully, we don't have to repeat our code here. Instead, we can add a new route definition here, where we set the path to :event ID. So the same path as we have it here. However, this will be a route that does not render an element. I will not add element here. Instead, I just add children. And the children of this route will be this route, where I now set the path to an empty string, or better, I simply set index to true. And this route here, where I remove this dynamic path segment at the beginning. This is also how you can use nested routes to construct a URL with the parent route URL and the child route URLs. Now here we don't have element because I don't want to have any shared layout or anything like that. Instead, I'm using this approach because I want to add a loader here to this route, this event detail loader. I remove it from the event detail page route and add it to this wrapper route. So you can also use this nested routes feature not just to use a wrapper layout component, but also to use a shared loader, for example. Because as you learned before, you can access loader data with use loader data with this special hook provided by React Router in any component that's on the same level or a lower level than the route where the loader is added to. So with that, this loader will execute whenever we visit this or this route. And that, of course, then allows us to reuse the logic and data of that loader in both these routes down here. So therefore now in edit event, we can also use the use loader data hook, which we must import from React Router DOM. So here I import use loader data. And that gives us access to the data object, which, as we learned before, includes the event which we need under the event property. And now we could pass the event to the event form here, like this, or just like this and omit this step. And in event form, we can now use it. Here, we can accept such an event prop. I actually already added the code for doing so here. I'm extracting this event prop with object destructuring from my props object. And then we can use this event value to set some default values on these inputs with the default value attribute provided by React. This allows us to set the default event title, for example. We just want to check whether we have an event before trying to access it. So here I check if I have an event. If yes, I populate this input with the title of this event. Otherwise, I set this to an empty string. And then I repeat this here for this image input and also for my date input here. And then also for the text area where I set this to event.description. With that, we're using this event data to pre-populate the form. And if we try to view the form, we're greeted with an error. The reason for that is that by default, when we use loader data, it searches for the closest available loader data, and the highest level at which it looks for data is the route definition of the route for which this component was loaded. So in this case, the highest level it looks for data is this edit route here. Now we actually want loader data from this route. And to make sure that we use this loader's data instead, so the data from this parent route, we should add a special ID property, which we can add to our route definitions. And for example, name this event detail. This ID is totally up to you though. And then, instead of using use loader data, we use a slightly different hook, which is called use route loader data. This hook works almost like use loader data, but it takes a route ID as an argument. In my case here, event-detail, the ID I just assigned to my route. So this ID here. And I use the same hook here in edit event. Here we use route loader data, use route loader data, and use that ID which we assigned. With that, you see now it loads and it populates this form with the loaded data. So that's how you can get access to a higher level loader from a route that doesn't have a loader. You use route loader data instead of use loader data. But now we can reuse that loader across multiple routes which all need the same data. And reusing code is of course always a good thing. Okay, finally, now that we loaded a lot of data in a lot of different ways, and that we now hopefully get the hang of how loading data works with React Router, it's time to also send data to the backend. Because we, for example, get this edit form here, but we could also be adding a new event. And for that, of course, we want to display a form here as well, and then ultimately send the data from that form to this dummy backend which we have here. Now I'll start by displaying the form. For that, I'll use that same event form component here in my new event.js file. Here we just return event form and include that import to that component, of course. Now if we visit new event, we see that same form as we saw before when we clicked edit, but of course without any pre-filled data because this is a new event which we add here. Now we want to make sure that whenever we click that save button and we entered some data here, that data is sent to the backend API. How can we do that? Well, there are different approaches. We could add a function here in our new event page component and give that function a name like submit handler, accept an event here, and that event would be the submit event of our form. And we could call prevent default to make sure that the browser does not automatically send a request to the backend. And then we could extract data from the form with help of two-way binding or refs, for example. And we could then manually send our HTTP request here, maybe manage some loading and error state, and ultimately navigate away from this page once we're done. We could navigate away with imperative navigation with help of that use navigate hook I mentioned earlier in this section. We could do all of that, but as you can probably already tell by the fact that I'm saying could, there is a better approach when using React Router. Just as we can add loaders to load data, we can also add actions to send data, and that is what we should do here. So to add an action to this new route here, we add the special action property here. And just like loader, action wants a function, an arrow function or a regular function. That does not matter. Now, just as with loaders, we typically don't want to add our action functions here in our route definitions file, but instead we want to keep that code close to the components to which it belongs. So here in this case, we might want to add the action function in the new event.js file. So here we can export a function called action. The name is up to you again. We can add the async keyword here if we want to use async await in here. And now in this action function, we can send requests to the backend. Now what's again important to understand and keep in mind is that we're still on the client side here. Just as with the loader, this is code that executes in the browser. This is not backend code. You can access any browser API here, like for example, local storage. But very often you might want to send a request with the good old fetch function again. And here indeed I want to send a request to localhost 8080, so to my dummy backend API which listens on port 8080, and there /events. And I actually want to send a post request, which we can do like that, and add some data to the request. And here the data I want to send is that data that was submitted with the form. Now, the great thing about React Router is that it makes handling form submissions a breeze, and it helps with extracting data from that form. For that, you should go to that form and make sure that all your inputs have the name attribute, because those names will later be used for extracting the data. So these names here must be set on all your inputs and text areas. Next, you should replace the form element with the special form component, which is provided by React Router DOM. So you should import form from React Router DOM, and then replace the opening and the closing form tag with that form tag. It's the same tag, but with a capital F at the beginning. Now this form tag will make sure that the browser default of sending a request to the backend will be omitted, but it will take that request that would have been sent and give it to your action. And that's pretty useful because that request will contain all the data that was submitted as part of the form. Therefore, what you should do here is you should add the method property and set this to post, for example, though this form component also supports other HTTP methods like delete or patch, but here I'll choose post. But this request, and that's important, will not be sent to the backend automatically, but instead to your action. And it will include all the form data if you use this special form component. Now with that, back here in new event.js, we are in this action function. And to get hold of that request that is captured by React Router and forwarded to that action, we have to use the data that's passed to this action function. Because just as the loader function, the action function is executed by React Router, and it receives an object that includes a couple of helpful properties. To be precise, again, the request and params properties. Now this time we're not interested in the params because I have no params here when creating a new event, but I am interested in the request object because that request object contains the form data. To get hold of that form data, we have to call the special form data method on the request object and await it. That will give us a data object that includes this form data. And on this data object, we can call the get method to get access to the different input field values that were submitted. To get, we pass a string with the different identifiers of our input fields. So that would be the values we chose as names for the input fields, like title or image in my case. So we could, for example, get the title like this. The entered title could be extracted like this. And of course, that can be repeated for all the fields, and I will simply create an event data object here where I have my title, which is set equal to the extracted title like this, where I then have my image like this, where I then also have the date that was picked and submitted, like this, and where I get my description, like this. So that's how we can extract this submitted form data with help of that request that's forwarded or that's passed into this action function by React Router. Now with that, it's this event data that should be sent to the backend, and we have to convert it to JSON here by wrapping it with JSON stringify. And I'll also add some extra headers where I set the content type to application JSON so that the data is handled and extracted correctly on the backend. This will then give me a response if we await this here, and then we can look into this response, extract the returned data, and do whatever we need to do. We can, for example, again check if it's maybe not okay, and in that case, throw an error response with that built-in JSON function, which we can get from React Router DOM. And that would then display our error page if we throw an error response like this. So this works for actions just as it worked for loaders. So here we could then have a message where we say could not save event and set the status code maybe to 500 again. We can also return data from an action, and we will do so soon, but for the moment, that's the basic action code that I want to have for handling the submitted form and for adding a new event by sending that new event request to the backend. With that action defined, we can go back to app.js, and there we can now import this action from new event. Here, action as new event action. We can import this and then use this new event action down here as a value for this action property on this route definition. With that, if we save everything, we should be able to create a new event here. For that, I'm also picking some image here and enter this image address, then pick a date and add a description. If you now click Save, it looks like nothing happened. But actually, if you click on Events, you should see that your event was added. But why did nothing happen after clicking Save? Well, because we didn't specify what should happen thereafter. And typically when submitting a form, what you want to happen is that you navigate the user away to a different page after successfully submitting the form. To do that, we can go back to our action in new event.js and then return the result of calling redirect. Redirect, like JSON, is a special function you can import from React Router DOM. And like JSON, redirect creates a response object. However, it's a special response object that simply redirects the user to a different page. Now the heavy lifting is handled behind the scenes by React Router. Here you just specify the path to which you want to redirect the user, and React Router will take care about the rest. So for example here, if I add another event, another amazing event, now I'm redirected. And that's how you can handle form submissions with help of actions like this. So we learned how we can use actions to submit data or react to the submission of forms and leverage this React Router feature to outsource that code that should run upon a form submission from our components into these separate action functions here. Now, before we take a closer look at what we can do with such action functions, I want to show you a different way of triggering such an action function. The typical and default way is to use this special form component offered by React Router. That's the standard way you should use. This form will automatically trigger the action function of the currently active route, so the route for which this form was loaded. Now you could send the request to a different route by adding the action prop here to this form component and setting this to any other path. then in that case, the action of another path, of another route definition object would be triggered. So if you had an action on some other route here, you could point at that action by simply setting the form's action prop value to the path of the route for which you want to trigger the action. But if you want to trigger the action of the currently active route, you don't need the action prop. But that's just one of the things I want to show you. I also want to show you a totally different way of triggering an action. And for that, let's take a look at the event detail component here, this event detail page. There we display the event item component, and this event item component actually has a button that allows us to delete events. Currently it's not working because the function which we trigger upon a click on the button doesn't do anything. Now it would be reasonable that here in this function we maybe first of all want to prompt the user whether he or she really wants to delete this event. For this we could use the built-in confirm function that's built into the browser and ask, "Are you sure?" And this will return a boolean, so true or false. And if it's true, so if we're in this if block, then we might want to trigger an action that goes ahead and deletes this event. Now for that, as a first step, we must add an action that should be triggered. And since event item will be rendered as part of the event detail page component, which is loaded for this event detail route here, we should add the action to this event detail route. Alternatively, we add the action somewhere else and we make sure that we send the request to a different path. But I'll get back to this in a second. For the moment, I want to add the action here to this event detail page route. And therefore here in event detail.js, I will add this action function just as I added the loader function here. So here I add the action function, can be an async function so that we can use async await. And here we then want to add the code for deleting an event. For that, we want to use the good old fetch function again to send a request to the backend. And here the URL and the path to which we need to send the request is /events/ and then the ID of the event that should be deleted. Now we can get that ID with help of the params object, which we get for actions just as we do for loaders. So here we got the event ID by accessing params.eventID, which is exactly the same approach we take in our loader here. Now we can add that here in this URL. We can then await this and we get our response. And just as before, we can check if our response is okay. And for that, I'll just copy the code from the loader and just alter the error message if we have an error where I say could not delete event, because that's what we're trying to do here. And else, if we are successful, we know that, well, we're done and we want to probably redirect the user. So here in that case, if we make it past this if check where we check if the response is okay, I will return redirect to redirect the user and load a different route with help of the built-in redirect function, which is imported from React Router, and redirect the user to, let's say, events, so to a list of all events. That's what we can do here. And now, since we're exporting this action here in app.js, we can import it as delete event action, for example, and then assign this to the action property of this route. But how do we now trigger this action? That was the part I wanted to show you. We could theoretically go to event item and wrap this button with a form. We could add this form component here, but in that case, we would not be prompted whether we want to proceed. We wouldn't see this confirmation prompt. And I want to see that to give the user a chance of canceling the deletion process. So we need to trigger that action and submit some data, so to say, programmatically. And just as we can navigate programmatically, we can also submit data and trigger an action programmatically with the special useSubmit hook. This hook is imported from React Router DOM, and it gives you a submit function, which I'm storing in a constant here. And we can call this submit function here if we want to proceed. And to this submit function, we can pass two arguments. The first argument is the data that we want to submit. And that data will automatically be wrapped in a form data object, which we then could extract with this special form data method we saw when creating a new event. So this method. The data we pass to the submit function would automatically be wrapped with such a form data object. But here I actually need no data, so we can set this to null. The second argument then allows us to basically set the same values we could set on a form. For example, the method, which we can set to delete in this case, which would be an appropriate method for this client-side request, which is handled on the client side and which triggers this action function as you learned. And we could set the action key to a different path if our action would be defined on a different route path. In this case, it's defined on the same route to which this component belongs in the end, or for which this component is rendered in the end, and therefore we don't need to set the action. Now, the method currently also doesn't matter, but it makes sense to set this to delete, and I actually now want to use it in event detail. Because if we just send our request like this, we wouldn't delete the event, because that's not the kind of request our backend is waiting for when it comes to deleting events. Instead, we need to configure this request, which we're sending here, and we must set the method to delete, like this. And of course, we could also dynamically extract the method from the submitted form, so to say, by using this request object, which we also get here in this data object that's provided to the action function by React Router. And then we could set the method of the request we're sending to the backend equal to the method that was used for this client-side request that was generated by React Router. And now all of a sudden the method we do set here in this line of code does matter because we're using this method in our action. I could have hard-coded this method here to delete, but I also wanted to show you how you could access this method that is set when the form is submitted or when data is submitted, in this case with this use submit hook and the submit function. And that's how you can submit data and trigger an action programmatically. If you save all your files, you should be able to click delete. You get prompted whether you want to proceed and you can cancel this, but you can also confirm it, you will be redirected, and indeed the event was deleted. We're making good progress. Now I want to again go back to my backend code real quick here, and under routes events.js in this post route, which will be triggered whenever we try to save a new event, I want to add a short delay again. By the way, here you also see that I have some server-side validation where I check the submitted data and where I might return an error response if invalid data is submitted. But I'll get back to this later. For the moment, I want to focus on this success case here. And again, I'll add set timeout here to wait for 1.5 seconds before sending this success response, like this. Just as before, we should restart that backend server for these changes to be active. Now I'm doing this because I want to show you that if you add a new event, as I'm doing it here, the submission will now take a short while. And just as before, when we navigated to a different page, we don't get any feedback regarding that. And it would be nice to get some feedback and maybe also to disable the save button so that users don't try to submit the same form multiple times. Now we can get and incorporate that feedback just as we did it before. I, by the way, also added programmatic navigation here for this cancel handler, but that's not too important. Instead, I want to use a hook that sounds familiar to use navigate but works totally different. The use navigation hook. And that's a hook we already saw in action before. It's provided by React Router and gives us access to a navigation object. And we can extract various pieces of information from that object, for example, also data that was submitted. But we can also find out what the current state of the currently active transition is. And we have a transition from one route to another if we click a link, but we also have a transition if we submit a form. And therefore, we also get information about the current data submission process and whether it completed already. So whether the action that was triggered completed already. So here we can add a helper constant called isSubmitting. And in there, I simply store the result of comparing navigation.state to submitting. If the current state is submitting, I know that we are currently submitting data, so that the action that was triggered is currently still active. And we can use this isSubmitting field here to, for example, disable this save button. We can disable it by simply setting this to isSubmitting. So if we are submitting, this button is disabled. We can do the same for the cancel button if we want to. We can also change the text of the button and check if we are submitting, in which case I'll set the text to submitting, and only otherwise I'll set it to save. With that done, we can add a new event, testing, set it to any date, of course, and add any text. And if I click save, you see this changed to submitting, and I now get some feedback that something's going on here, which is better than having no feedback at all. With that done though, I can go back to this backend code and again remove this set timeout code from this routes events.js file, because that was just a demo, but it's important to understand how you can manage those different states. Now, when we had a look at this backend code before, when I added this timeout code, this delay, I also mentioned that I do validate the user input here on the backend. And I, of course, have this validation code so that no incorrect data gets stored in my database, or in this case, in this file, which I'm using here. Now, I also have some validation on the front end. On my form inputs here, I have these default HTML attributes, which in this case ensure that I can't submit empty input values. But you should never rely on just client-side validation. You should always have server-side validation, because client-side validation can, for example, be turned off and disabled with the DevTools, with the browser DevTools. Nonetheless, it's good to have both to provide a good user experience. But I, of course, want to show the user any errors, any validation errors that I gathered on the backend in case some validation errors were detected here. For example, because the user did disable client-side validation. And to do that, I want to leverage the fact that on the backend, I'm sending back an error response with status code 422 if I found some validation errors there. On the front end, in the new event page component file here, for example, in this action where I do submit the data, I want to react to such potential backend validation errors. And I want to react by not showing my default error page, so I don't want to throw an error response, but instead I want to show such validation errors here, right above this form, because that makes more sense than showing an error page, because that would discard all the values entered by the user and not really offer a good user experience. Therefore, I want to stay on this page, but I want to output some data. And you can easily do this in actions by returning the data you want to output above the form or anywhere in your routes. For that, I will simply check if my response status code is equal to 422, which is that validation status code I'm setting on the backend in case of validation errors. And if I have that status code, then I want to return my response. So I'm not returning and redirecting.
And I'm not throwing an error response, but I'm returning the response I got back from the backend if I have this 422 status code on the response. Now, what does returning a response in an action do, though? Well, just as we can return responses in loaders and then use the response data in our components and pages, we can also use returned action data in our pages and components. It's just less common, but it's very common for such validation error responses where you don't want to show an error page. We can go to the event form component, which is in the end rendered by the new event page component here. And in that event form component, I can use another hook provided by React Router DOM, and that's the use action data hook, which almost sounds like use loader data, which is no coincidence because it does basically the same thing. It gives us access to the data returned by our action in this case, not by the loader, but by the action, and it gives us access to the closest action. So I can use this in this component here, even though it's not the page component, because it's rendered by the page component for which this action was defined, where I return that response. So with that in event form, I get this data object here. And if I return a response in an action, this response is automatically parsed by React Router for me, just as it is the case for loaders. And therefore here, this data is the data I return on my backend in case of validation errors. And that would be an object with a general message and a nested errors object, which has different keys for the different inputs with more detailed error messages, if you want to call it like this. So therefore here in event form, inside of my form, for example, I could check if data is set, because it will not be set if we haven't submitted the form yet, for example, because that data is coming from an action. You must not forget this. So I check if I have data, if I submitted the form and the action returned some data. And then I check if I have this errors object, this nested errors object on my data, in which case I want to return or output an unordered list, where I then use object.values, a function built into JavaScript, to basically loop through all my keys in this errors object and map my data here, the data that's stored for these different keys, to list items. Every list item receives the special key prop, which is expected by React, and I set it equal to the error message I'm having here, and I output the error message. So that's how I'm outputting these validation errors I could be getting from the backend. And to show you how this works, I will submit this form without any values entered. For that, I'll first of all inspect it in my DevTools and remove these special attributes that would normally prevent me from submitting invalid values. If I disable it like this, I will be able to submit the form without having entered correct values. So that's what I'm doing here for all these inputs. And now if I click Save, you see that here I'm getting these error messages, and that's coming from my action where I return that response, which I'm getting from the backend. And I'm then picking up that returned data from the action with help of use action data, and I'm outputting the data that's part of that returned response here in my JSX code. Okay, so now we added almost all functionalities except for editing. That's still not entirely working as it should. Or to be precise, we can't really submit this. We get an error if we try to do that. The reason for that is that at the moment we're simply not supporting submission for this edit event page component. We're rendering the event form there, and the event form has a form component which tries to submit the form data, but we haven't registered an action for this edit event route. Here, for this route, there is no action. Now, actually, the action which I do want to trigger here is almost the same as for the new event route. We want to send almost the same kind of request to just a slightly different URL with a different request method. But other than that, it's basically the same action which I want to trigger because it's the same form with the same data. So it would be great if we could reuse that action which we're using for creating a new event. And we can. For that, I'll grab this code here where I define and export my action in new event.js. And I'm adding it to event form.js, but I could be adding it to any file. We could also create a brand new utility file that stores this action. Here I'm adding it to event form though, and I now want to change it a little bit. I want to make the code in this action a bit more dynamic to be able to send both a request for adding a new event as well as for editing an existing event. And how could we do that? Well, we could make sure that in our event form, we use different methods for creating new events or for editing events. We can use post for creating new events and patch for editing an event. And I'm actually expecting a method prop here. I'm already extracting it with object destructuring, which I can set here. And this could now be set from inside new event and from inside edit event. In new event, I could set method to post, and in edit event, I could set it to patch. So that would set the method of the form, and I could use the same form with different methods. Now, how is this method helpful? Well, we can get access to that method here in our action on this request object. There we can extract the method like this. Now, this method can be used to set the method of the request we're sending to the backend. Again, here we're still on the front end, but we're sending a request to the dummy backend here. And instead of hard coding this method here, I can set this method to the method of the request that was generated by React Router. Now, the URL also needs to change though. It's not always the same. The URL is this URL here if we're creating a new event, but it's actually this URL plus the event ID if we're editing an existing event. So here I'm using this URL variable, and I'm then checking if method is equal to patch, which means we're editing an event instead of adding an event. And in that case, I want to get the ID of the event which we're editing by accessing my params here. So this params object, which we also get from React Router in this overall object that's passed to actions. And here I can extract event ID. Now event ID here, because in my route definitions, I chose event ID as a placeholder name. So with that, I'm getting the event ID if I know that the action was triggered because I submitted the form for editing an event instead of adding. And in that case, my URL is basically this URL plus event ID and an extra slash added here. With that, I have a dynamic way of sending a request to different URLs with different methods, but with always the same data depending on how this action was triggered. Now we just must make sure that this action is used on all the routes where we need to use it. And for this, I go back to app.js, and instead of importing the new event action here from pages new event, I remove that, and I instead import my action as manipulate event action, or however you want to name it, from components event form, because that's where we just added the action to. And now it's this manipulate event action, which I add to both my new event page route here, as well as to this edit event page here. So we use the same action on different routes, but this action is written such that it will do slightly different things depending on how the form was submitted. And that should allow us to use the same form with different actions. Now I'm getting an error here where I'm missing some imports, which makes sense. In my new event.js file, I was importing JSON and redirect, which I no longer need to do here. But these imports are now needed in event form because here in my action, I'm using JSON and redirect. So I should add those imports here and import JSON and redirect from React Router DOM. And with this all compiles successfully. Now, if I try to add a couple of exclamation marks to this title and I click save, I get an error. Now I'm getting this error because actually I'm checking for patch all lowercase here, but the request will include it in all caps. So I wasn't extracting my parameters and setting the URL correctly. But if I check for patch all caps here, which is how it's written in this request object that's generated, which you can tell if you console log this request object like this. If I do it like that, you will see that now if I add a couple of exclamation marks here and I save this, this was updated. And of course I can still add a new event. If I add one here with a URL that doesn't exist, but it doesn't matter, we can delete it anyways, you will see that this also is created. And of course we can edit this or delete this. And I'll delete it here because we don't need it anymore. But now we're able to delete and edit events with the same dynamic action code being used and by utilizing this method, which we can set on the form. And again, this method is only used to set the method for this client-side request, which is generated by React Router and which is passed to action. And it's exactly this client-side request, which we're then using in the action to extract the method and configure our backend request, which we send to the backend appropriately. Now, slowly but steadily, we're coming to an end of this arguably really big module, but there is a lot to teach regarding routing, as you can tell, and this is the complete guide course, after all, not the I just teach you some parts of it guide. But still, we're getting closer to concluding this module, but there still are a couple of important features offered by React Router you should know. And to introduce the first feature, you find a couple of updated code files attached to this lecture. You find an updated main navigation.js file where I added a new link and this new newsletter sign-up component, which is another component you find attached, newsletter sign-up, which renders a simple form with an input which could be used by users to sign up for an imaginary newsletter. There also is a CSS file for this component attached. Then I added the newsletter.js file, which should go into the pages folder, which also renders this newsletter sign-up component wrapped into this page content component, and where I defined a dummy action that doesn't really do anything, but that does extract the provided email. And we could then send it to some backend server, but here we're not doing anything with it because we don't need to do anything with it for this demo. And in app.js, I also added a new route, and therefore you find the updated app.js file attached. I added this newsletter route on the same level as my homepage route, essentially. And this route renders the newsletter page component, which I just showed you, and has the newsletter action attached to it. Now, I did add these components and this route because there is a new feature I want to show you, as mentioned. And for that, it's important to understand that we have this newsletter sign-up form both on the newsletter page as well as on every other page because it is included here in the main navigation. So it's not just on one single page, but on all pages. The problem with that is that, of course, we want to trigger this action, this newsletter action, whenever this newsletter form is submitted. And if we are on the newsletter page, if we are on this page, that would be quite straightforward to do. All we had to do is go to the newsletter sign-up component, which is where we have this form, and use React Router's form component here, which starts with a capital F. And as you learned, that would automatically trigger the action that belongs to the currently active route. The problem is, however, that this form is included on all routes because it's part of the main navigation. This newsletter sign-up component is part of the main navigation. Therefore, we would have to add the action to all routes. And that would, of course, be a lot of code duplication and also clash with other actions that we might need for other routes. Now, this is such a common use case that React Router has a solution for it. There is a special hook which you can import from React Router DOM, and that is the useFetcher hook. The name might be a bit strange, but this hook, when executed, gives you an object, and this object includes a bunch of useful properties and methods. For example, it gives you another form component, which is different from that other form component we used before. It also gives you a submit function, which is different from the submit function we got from useSubmit, which we used before. But what is the difference between this form we get here and this submit function which we get here? Well, if we use this fetcher's form component like this, which we can, then this will actually still trigger an action, but it will not initialize a route transition. So fetcher should basically be used whenever you want to trigger an action or also a loader with help of the load function without actually navigating to the page to which the loader belongs or the page to which the action belongs. On this form here, we can add the action attribute and, for example, point at /newsletter because I know that I want to trigger the action of that newsletter route. But I want to make sure that I don't load that route's component. I don't want to load the element that belongs to this route. And with the default form, we would do that. If I add form here without fetcher, just to show you what the difference is, you will notice that if I set up this form like this with the default form provided by React Router, if I go to events and I then enter some email address here, I'm forwarded to the events page after submitting this. And that's not the behavior I want. Now it changes if I use fetcher.form, because as I mentioned with fetcher, we don't transition. We don't move to a different route. So now we can get rid of the form import and use fetcher form instead. And now if I'm on events and I enter my details here, now I submit this without transitioning. Now we don't get a feedback because I haven't added any logic for this, but we saw before that it seemed to work since we did transition with that other form. And we can get a feedback by using other properties provided by Fetcher, because useFetcher, this useFetcher hook, is basically the tool you should use if you want to interact with some action or a loader without transitioning. So if you want to send your requests behind the scenes, so to say, without triggering any route changes. And because that's the goal, or that's where Fetcher wants to help you, this Fetcher object also includes a bunch of properties that help you understand whether your action or loader that you triggered succeeded. You also get access to any data returned by that loader or action. You get access to that data through that data property here, to be precise. So we can actually use object destructuring to pull out that data property, that data object, which is returned by the action or loader that's being triggered. And you can also get hold of a state object, or a state value to be precise, which is equal to idle, loading, or submitting, which you might know from the useNavigation hook. But useNavigation was meant to be used with actual route transitions. The state you get from Fetcher instead tells you whether the Fetcher, behind the scenes, completed its loader or action that was triggered. So we can then use this to update the UI accordingly. For example, we could bring back useEffect, the regular good old useEffect from React, and trigger a function whenever data and state changed, so whenever one of these two values changed. And we can check if state is equal to idle, which means we're not executing an action or a loader anymore. And we can check if we got data, and if that data got a message property, because actually my newsletter action does return an object with a message property. So that's what I'm checking for here. And if that's all the case, we could use the built-in alert function to say sign up successful or anything like that. We can actually also just output data.message. That might be even easier. We could, of course, also do other things and, for example, clear the input or do whatever we want to do. But this is also a way of getting access to the data and the state of our behind-the-scenes action or loader execution. And therefore, with those changes applied, if I now submit this again, I get this alert here. So useFetcher is the tool you should use if you want to trigger a loader or an action without actually loading the page, the route to which this action or loader belongs. And it's perfect for scenarios like we have it here, where you might have some shared component or a component that's used multiple times on the same page and where you just want to update or get some data behind the scenes. Now, to come to an end for this module here, I want to introduce one last feature you should also be aware of. And that's a feature that allows you to defer when data is loaded. But what does this mean? Well, to show you what it means, let me go back to my backend code, to routes events.js, and here at the very top, this get route, which is responsible for returning a list of all my events. Here I want to bring back a timeout. And I want to slow this down and make sure that my response with the events is only sent after 2 seconds. Now, just as before, we should restart that backend for these changes to have an effect. And now if we would go to another page and back to the events page, you will see that it takes some time for this page to load. And we did discuss this earlier already, and I did show you how you could show a loading indicator with help of the use navigation hook. But sometimes you want to load this page before the data is there and show parts of the page already until all the data is there. For example, here, it would make sense to show these buttons already, the all events and new event buttons, even if the list of events hasn't been loaded yet. But at the moment, we don't see anything until the events are there. And that's where we can defer loading and tell React Router that we actually want to render a component already, even though the data is not fully there yet. And that's exactly what we'll implement now. For that, we can go to events.js, which is where we are loading these events. And in order to defer loading that, what we need to do here is we need to grab that code here and outsource it into a separate function, an async function, which I'll name load events, and then I put my code in there. So it's almost the same code as before, just wrapped into a separate function. I'm doing this because in the loader, I now don't want to await this promise here. Instead here, I can actually get rid of this async keyword and use a special function in this loader function, the defer function, which should be imported from React Router DOM, this defer function. Now, defer is a function that must be executed, and to defer, we pass an object. Now, in this object, we in the end bundle all the different HTTP requests we might have going on this page. In this case, it's only one request, though, the request for all my events. I'll give that request a key of events, for example, though that key is up to you. And then here, I'll point at load events. I'll actually not just point at it, instead I will execute it. So I add parentheses here. So I execute the load events function and I store the value returned by load events, which is a promise, since this is an async function, in this object under the events key. Now we must have a promise here. If we wouldn't have a promise, there would be nothing to defer, because the idea behind defer is that we have a value that will eventually resolve to another value, which is the definition of a promise, and that we want to load a component and render a component even though that future value isn't there yet. So load events returns a promise, it must return a promise, and it does, and we store that promise under the events key in this object, which we pass to defer. And it's now this value returned by defer which we return in our loader. Now this is not everything we have to do though. Instead, now as a next step, we have to go to the component where we want to use the deferred data, and we still use loader data here. We still do that, but this data will now actually be an object that gives us access to these deferred value keys here, so to events in my case. And here in this component, we now don't directly render the component or the JSX code that needs our data. Instead, what we do in here is we return another component provided by React Router DOM, and that's the await component. So we render await here, and await has a special resolve prop, which wants one of our deferred values as a value. So here on this data object, we know that we have an events key because that's what we set here. So this data object here will have the keys we set in this object that we pass to defer. And that events key will in the end hold a promise as a value. So it's kind of that promise which we want to pass to this resolve value of the await component. So here I'll actually use object destructuring to get my events key and pass this to resolve here, like this. Now that await component will wait for that data to be there, and then between the opening and closing tags, we output a dynamic value, which must be a function that will be executed by React Router once that data is there. So once that promise resolved, once we have that data. So here we therefore get our events in the end, our loaded events if we want to call it like this. Again, this function will be called by React Router once the data is there, and it's therefore now here where we want to output our events list and pass these loaded events as a value for the events prop. Now as a last step, we have to add another component that must be wrapped around the await component, and that's the suspense component, which is imported from React. So not from React Router, but from React. The suspense component is a component which can be used in certain situations to show a fallback whilst we're waiting for other data to arrive. We'll see it again later in the course in a totally different scenario, not related to routing, but here it is a component that's supported and used by React Router and by the await component to show a fallback whilst we're waiting for these events to be fetched. So here the fallback which I do want to show is actually a paragraph where I say loading, and I will add some inline style here, quick and dirty, to set the text alignment to center. And that's how we can defer data loading. A couple of steps, as you can tell, but now with that we'll load this events page component and render this component before we have the data. And we'll show this fallback until the data is there. So if we now save all files, and we go to home and then events, we see that loading text here. And then after 2 seconds, we get an error. Now I'm getting this error because in my load events helper function, I'm still returning the response. And whilst this did work before, where this was the value that was received directly by use loader data, this does not work anymore if we have this defer step in between. What I have to do instead is I have to manually parse that here. So here I got my response data by awaiting for response.json. And then here I return res data.events in this load events helper function. That's required because we have this defer step between our loader and useLoader data. With that, if I now go to home and back to events, we got this loading text here, and then we see those events here. So that's this defer feature in action, and this defer feature can speed up your pages and make sure that you're already showing some content whilst you're waiting for other content. It especially shines if you have pages with multiple HTTP requests with different speeds though. So how does this defer feature shine if you have multiple requests with different speeds? Well, for that, let's go to the event detail page. Here, we're only outputting the event item, but I'm going to change this. Besides the event item, I also want to output my events list here. So therefore, we of course must fetch the events on this page here as well. To do that, I'll quickly copy that load events function from events.js. We could also store it in another shared file and export it, but here I'll quickly copy it and paste it here above my loader in the event detail.js file. I will also add another function in this event detail.js file, which I'll name load event, where I expect to get the ID of an event. And I'll put that code here, which is responsible for loading a single event, into this load event helper function here. Now, just as before, I will also change this return value here of load event to manually extract the data. So just as in load events, I'll use the JSON method and await it, and then return restData.event here in the end. So now I got these two helper functions, and I will now use it here in this loader function. Because here I now want to actually defer again. So I will return defer, and for that, of course, we must import defer. And I will defer here because we know that load events will take a while because we have this 2-second timeout on the backend, whereas load event should be rather fast. And I want to show you how defer can help you load some data whilst still waiting for other data. So here, when calling defer, I pass an object to it. And I have my single event where I will call load event and pass this ID, which I'm extracting from my params, to load event. And I have events where I call load events like that. And of course, that should also be executed. So now this is looking similar to what we had before in the events.js file, but we have two requests that are bundled in this defer object. Now with that done, we're using useRouteLoader data here, but that works with defer just as useLoader data did. And we know that here we'll get an object that has an event and an events key. These are these two deferred requests, so to say. Now we need the await component, which I showed you before. And we use that await component 2 times to await these two different requests. So here I pass event to the resolve prop, and then I pass events, plural, to the resolve prop. Then we got these dynamic values between the opening and closing await tags, where I got my event in this first case, or let's maybe name it loaded event, where I then want to output the event item once that data is there. So here I pass loaded event to the event prop, like this. And then here for the second await block, I got my loaded events, and I will output those here. Now we also need suspense, and every await block must be wrapped with its own suspense component. Otherwise, suspense will wait for both awaits to complete before showing anything, which is not what we want. So we need to import suspense and then add our fallback here. Again, a paragraph where we maybe say loading with that inline style added here like this. And I'll use that same suspense block down there to wrap my second await. Now what does this do? Well, if we save that all and I click on an event, you see that the details were there basically immediately, but the list of events was still loading. Let's take a look at this again. If I go to my events and I click on a single event, the details are there immediately and the other list of events is still loading. By the way, those links in this nested list would now be broken. To fix that, we would have to go to events list.js and then convert these links to absolute links here, since we can now end up in situations where this component is rendered on a page where adding this to the currently active path would lead to an overall incorrect path. But that's just a tiny side note, not related to deferring data loading. But what we do get with that is now a page that's instantly available whilst still loading other data that's not instantly available. However, this is still not the perfect solution. The backend here is super fast, but you can sometimes see a loading message here for these details for a short fraction of a second. Because we're actually deferring both pieces of data, the single event and all events. Now it would make sense to tell React Router that it should maybe wait with displaying the event detail page until the details have been loaded. So the navigation should only start once the details have been loaded. But it should then load the list of events after we navigated here. And defer gives you that fine-grained control. If you have an async loader with the async function, you can simply add the await keyword here, and that will make sure that defer waits for this data to be loaded before loading this page component at all, so before moving and navigating to this page component, but will load this data, the load events data, after the page was loaded. So await is your lever, your switch for controlling which data should be awaited before moving to this page and which data should be deferred, so where you want to load the data after moving to the page. And with this setup here, we would wait for the event details to be loaded before loading this page component at all, but we would load the list of events after rendering this page. Here you won't see a big difference, but it will actually ensure that we never see a loading text here for the event details. And that's how you can use defer to control when which data is loaded. Now that's it for this course section. To fully conclude it, I'll just finalize this homepage component and render my page content component here, which is imported from components page content. And I'll set a title to welcome and add a paragraph where I say browse all our amazing events. Something like this. But that's just a tiny note, just a tiny change to make this homepage at least a little bit nicer. But that's it for this course section, and you did learn a lot about routing. You learned how you can generally configure routes and make sure that different components are loaded for different paths. You learned how you can handle errors and how you can set up layouts that wrap itself around multiple routes. You learned about nested routes, as you can see here, and most importantly, you learned about data fetching and submission. You learned how you can generally set up data fetching and submission with loaders and actions. And you learned about advanced use cases where you could use useFetcher to fetch or load data behind the scenes without navigating. And you learned about deferring data fetching, which can be helpful if you have some slow requests, some slow backend, and you want to show a page without waiting for the data to be there. Or if you have multiple pieces of data and you want to show some data before all the data is there, as we had it here with the single event and the list of events. You should not always use the for, but instead use it when you need this behavior, when you need to show something before all the data is there. We covered tons of features in this course section. It was a long section for sure, but I hope it's clear how you can generally configure routes, what the idea behind routing is, and how routing works. Definitely feel free to go back to individual lectures or to go through this entire section again, even though it was long, but maybe at double speed, so that you get all these concepts down and you fully understand how all these features work. Because once you start building real React apps, more complex React apps, you will almost always need routing. And especially the data fetching and submission capabilities of React Router can make that data fetching and submission part a breeze. You just need to understand how it works, and I hope this course section helped you with that.